Hello, am I audible?
Hello,
Hello, yeah,
Dr. S.V. Srikant?
yeah, this is Shrikant.
Yes, yes. Good morning, sir. I am Dr. Rathi from Shankara Institute of Technology.
Yeah.
Yes, welcome you, sir. We'll be
Thank-
starting just after a few minutes.
no issues, not a problem.
Yes, you are ready now. Otherwise, you are ready?
Yeah, I'm ready.
Yes, good. Okay, sir. Thank you. Yes, hello, Dr. S.V. Srikanth.
Yeah, hello, sir. Yeah.
Yes, sir. Yes, good morning to you, sir, and good morning to all participants. Dear participants, today we have Dr. S.V. Srikanth. As before he take over the sessions, I just give a brief profile. Dr. S.V. Srikanth is associated with CDEC Hyderabad for the last 16 years in the field of IoT and embedded system designs. His master's in networking and telecom systems from UK and PhD in the area of wireless heterogeneous network from JNT University, Hyderabad, India. His area of interest include Internet of Things, ubiquitous computing, wireless technology, embedded system design, and mobile communications. He is a member of CSI SIG for IoT. Dr. Srikanth has executed around 13 projects and has published 20 papers in various journals and conferences. He has also delivered talks in number of national workshops and conferences. Today, Dr. Srikanth is with us, and his topic of today's discussions with you is IoT architectures, protocols, and case studies. Sir, yesterday we had two sessions.
Yeah, okay.
Two sessions. One was taken by Mr. Dalbir S. Daya. His topic was application security analysis for IoT and mobile devices.
Okay.
And another speaker was Dr. Nanda. He spoke about introductions to all neurals, networks, and fuzzy logics and AI tools. He touched upon, Dr. Nanda touched upon the basic concept of IoT and this artificial intelligence and multiple layer of neurons.
Okay.
Illustrated with practicals examples. Most of his talks was completely practice based. He gave complete practical insight to the whole concept of on these topics. Then he touched upon neural network, fuzzy systems, evolutionary computations. So I welcome you again, sir.
Yeah. Thank you, sir.
I think, yes, now the number of participants is also good. Our participants are also quite interactive. They will be raising some, queries in between or later on. And the session is of 90 minutes durations. Last 5-10 minutes, you can leave for queries from the participants.
Sure.
And with all good luck, sir, you can, start your sessions.
Sure. Thank you, sir.
Yes,
Thanks for the nice introduction. I
Yes,
think
yes.
let me start off my session today. Okay.
Yeah, yes, yes.
I think it's visible, sir.
Yes, sir, it is visible.
It is visible. Yeah.
Perfectly, yeah.
Yeah.
It's okay.
Yeah.
Yes, carry
Yeah.
on, sir.
Thank you. Thank
Yeah.
you. Good morning, all. I'm Srikanth. I think Sir has already introduced me. I have been working from the last 16 years on this IoT and embedded systems. So let me give a touch on what exactly is IoT, how did it start, and where we are now. And in this session, I'll be talking about different architectures of IoT, the protocols of IoT, and some case studies. And in my next session, which is coming up day after, that will have a bit of practical approach where I'll be showing you how to push your data onto the cloud and so on. Okay. So let me start off the session, which is Internet of Things. I think a statement made by Mr. Mark Anderson where he says, a lot of things you want to do as a part of daily life can now be done over the internet. Am I right? I think it's true. Everything we are doing over the internet today. Am I right? So internet has changed our lives. Am I right? The way we communicate, the way we work together. So what is the future of internet? The future of internet, they say, is it's not going to be about people. People are already connected. It's going to be about things, smart objects, connected devices. That is what we are going to talk about today, basically. Okay. So if you look at the evolution of internet as a whole, how it was happening. So the thing is, as you all know, internet that is TCP/IP as we call, because that is a protocol which is being used in internet. So that came during 1970s. So during that time, internet evolution, it was called as Internet of Boffins, where boffins are nothing but scientists who used to use internet for their experimentation. So that happened between 1969 to 1995. Later on, it moved to something called as Internet of Geeks, where a lot of gadget lovers started using internet. So that was during the period 95 to 2000. But when the later it was pushed to the masses, that is we, where we used to go to internet cafes and use internet. Am I right? That was called as Internet of Masses. So that was during the period 2000 to 2010. But later on, now what we are seeing is something called as mobile internet. Am I right? Everything is on the mobile today. Everything, you might be listening to my session on the mobile. You may be playing around on the mobile today over the internet. People do a lot of things on their mobile today because of internet. That is why it is called as mobile internet. So that was the era of 2010 to 2020. But what is the future beyond it? So the beyond what people are expecting about internet is nothing but it's called as Internet of Things, where all the things are getting connected. together to talk to each other, to share information, and give you massive applications and massive case studies. That is what we are expecting from 2020 and beyond. So that is why we are going to look into this topic. So the thing is, if you look at the evolution of connected computing, what we call as evolution of connected computing, what people say is there will be around 50 billion devices getting connected together by the year 2025 and so. 50 billion devices getting connected together by the year 2025 and so. So are we prepared for that? Because there will be only 5 billion people, what they say is, and beyond, there will be 1 billion websites, but the things getting connected is 50 billion. What they say is by the year 2014 itself, the number of connected devices have surpassed the number of people living in this planet. Can you imagine that? So the thing is, we need to look at can the existing protocols work on that? Because we are all engineers. We should know can the existing technology work for this? We are saying everything should get connected to internet. So that is what we need to do today. We need to deep dive into this topic and see what exactly is IoT, what are the protocols of IoT, what is the infrastructure required for IoT. So the thing is, before starting my topic, we need to look at what are things basically. Because a lot of people think that already my mobile is connected to internet. Mobile is a thing. Why should I talk about IoT? But are these the things we are talking about? Because when I call about IoT, I'm talking about these things. Things are nothing but a small embedded devices. But the thing is, they're all low power, low memory, and which are running on batteries. Always remember that. Low power, low memory, and which are running on batteries basically. And apart from that, if you look at a thing generally has a sensor, a microcontroller, a communication unit, a power supply. I think I'll be talking about them in detail, but just keep that in mind. So I'm always talking about something called constrained devices. Constrained devices means which are low power, low memory, and which are running on batteries. Not your high power devices like your laptops, mobile phones, your desktops, and so. They're already connected. So always remember that these are completely running on batteries. Okay, these are completely running on batteries. They're small in size, low in cost, and minimum computing is there. And always remember that whenever I'm talking about a thing, so power consumption is the main design issue. Always remember that. Because as these are running on batteries, we need to give them life. Life is given by power consumption basically, am I right? The less the power consumption, more the life. Always remember that. That is what we need to look at. So keep that in mind. A disclaimer before starting my session is the thing is constrained device, low power, low memory, and running on batteries without manual intervention up to 5 to 6 years basically. Always remember that. Okay. So let me start off with this. So the agenda for my today's session would be like this. Something I'll start off with IoT history, then I'll get into IoT definition, then I'll get
Sir, can I interrupt you?
yeah, please.
Uh, that means you have said spoken 5 to 6 years basis.
Yeah,
That means
yes.
the life of this device is only for 5 to 6 years.
Sir, generally a battery has a life. Am I right? When you talk about a battery, if you take a AAA battery or a AA battery, the maximum life they have is even though you use or you don't use, it is 3 years. Right? So what they say is the life you need to give for any IoT device is it should be in years, not in days, basically. That is why power consumption has come into picture, basically. So the thing is, what they say is at least if we can give up to 5 to 6 years without any manual intervention, that is a good deal you can have. So I'll give you some examples, sir. Then you'll clearly understand
Yes.
why we need to talk
Yeah.
about that line. Okay?
Yeah. Yeah. Okay.
Because
Okay.
yeah. Uh,
Yeah.
so
Carry
the
on.
thing is, yeah. Let me talk about this. First, I'll be talking about a bit on IoT history. Then I'll be talking about something called as IoT definition. Then IoT definition, because the thing is, a lot of people have given a lot of definitions on IoT, but what exactly is the definition for IoT? So that I'll be talking about. Then I'll be talking about IoT infographic. It's information in a graphical way because the thing is IoT as an engineer we should know what are the components of IoT. Am I right? So just giving a definition, but what is a component? What are the components which make an IoT architecture? That we'll look at. Then I'll be giving about some examples which are the global. Then some case studies which we have executed at CDAC. I'll be giving you so that they are all live examples which you can see and explore. Then we'll get into the main topic, which is IoT technology, because IoT technology is not small. Because as I clearly put a question mark, that's a disclaimer that can the existing technology be used for IoT? Because a lot of people start thinking that we can use, but the problem is power is coming as a question basically. So that is the reason, can we use the existing TCP/IP protocol? Can we use the existing software? Can we use the existing hardware? So what is that exactly? Or should we come out with something new? Protocols or a lightweight protocols, what people talk about. So that is what we need to look at. Then I'll be talking about something called as IoT IPP model. I think that I'll take it in the next session, which is nothing but we'll take up an idea before you only. I'll take up an idea. I'll convert that into a prototype basically before you only. Okay. So that you can see how the data is going to the cloud. What is the cloud? What are the sensors? How do we integrate them? How to send them to the cloud and all? I'll be showing you a sample basically, so that you will get a clear picture of hands-on. So this will be my complete agenda for the 2 days, whatever sessions I have. Okay. So the thing is, let me get into a bit of IoT history. I think I'll not take much time on IoT history. I think, but you all should know that IoT. I think a lot of people feel that, according to you, when did IoT start? See, a lot of people feel that IoT has become a buzzing and trending topic today, some 4 years back, or 5 years back, or 6 years back, basically. But according to me, IoT is not 4 years back or a 5 years back or a 6 years back story. IoT is something started long back, but we are visualizing that today, basically. Am I right or wrong? So let me get into a bit of history, basically. The thing is, let me get into the year 1832. 1832, the thing is, there was a scientist by name Baron Schilling. He was from Russia, where he said that he was the one who started electromagnetic telegraph at that point of time. What is an electromagnetic telegraph? Electromagnetic telegraph is nothing but, it is nothing but a wireless communication. Am I right? Wirelessly sending messages. Wirelessly sending messages he was doing in the year 1832. But later on, that work was continued by Gauss and Weber. I think Gauss and Weber, you, me, and everyone know, because they are the units for electromagnetic flux. Am I right? So those scientists, they started communicating in Germany over a distance of 1200 meters. So that was a great achievement at that point of time. But that work was all obsolete. And later, I think we all know that Samuel Morse was the first person to send a wireless communication. That is the Morse code public telegraph, basically. Right? So he was able to send between two cities in America. So that was Washington D.C. to Baltimore. So, but the question is, why I'm talking about all this? See, the question is, here I'm talking about wireless communication, right? Today is not IoT successful because of wireless communication. I would say that is because of that only. Because today you want every device to get connected, every device to talk to each other, communicate to each other is possible only because of wireless. It is not possible with wired, always remember. So why I wanted to tell all this is wireless communication started long back only. So that's what we need to keep in mind. That means bits and pieces were happening. Today we are enjoying the fruits of that. Okay. Then in 1926, Nikola Tesla, I'm right. Nikola Tesla, I think today we see a lot of Tesla cars and all everywhere, autonomous cars going on. So he was the founder member of that, where he made a comment at that point of time in a magazine. He told that if complete planet Earth becomes wireless, the advantage we get is everyone will have a phone in their vest pocket. Are we having one phone in our vest pocket today? We have multiple phones in our vest pocket. Am I right? So the thing is, that's what the imagination was 100 years back. We are seeing the fruits today. So now, what do you need for IoT? Communication is already there, which is wireless. Now we need internet, we need web. So over the decades, 1969, 1974, TCP/IP started. TCP/IP was the one through which we are able to use internet today. Am I right? So that is how things were happening. Then we wanted web. In 1989, Tim Berners-Lee started www. Today, because of www, I'm able to do everything. Am I right? So that is how things were happening everywhere. Things were happening. So we have wireless communication, we have internet, we have web. Now we want things to talk to each other. Am I right? So that is what today the achievement of IoT. What you say is, a lot of people say IoT fan. What do you mean by IoT fan? That means remotely I'll be able to switch it on and switch it off. Am I right? So that is what people are talking about as IoT fans or IoT lights. I'll be able to control the lights remotely. I'll be able to switch on gadgets and all remotely. And so that is how we need to look at IoT today. So the thing is, if you look at, so a lot of history went on. So in 1990, I think John Romkey was the first person was able to develop something called as the first internet device. So he was able to take up a gadget in his office and remotely switch it on, switch it off. He took a toaster in his office and he was able to remotely. Is it not IoT? So when did it start IoT? 1990s basically. But we are visualizing that all that today. So the thing is, lot of work was happening like this. Lot of work was happening. I think until this guy who is called Kevin Ashton, he was the one who coined the name IoT, Internet of Things. Why? Because he was. I think we all know that need is the mother of invention, right? So he was given a problem statement by Procter and Gamble, P&G, where they said, "See, we are not able to track our things." I think P&G, we all know. I think they have various products, daily used products. We use most of them are P&G basically. So he was given that we are not able to track. Then at that point of time, he took up RFID tags and he said, why don't we use RFID tag to each and every product? They can be tracked over the server through internet. So then he realized that all these are things. They're connected to internet. Why can't I call them Internet of Things? That is how the name IoT came into picture. So he's Mr. Kevin Ashton. So he's the one who coined that name called Internet of Things. But I think we all know that a lot of work was happening like that. I don't want to get into much history basically. So we'll get into the technical details. So the thing is, I think we all know that unless and until United Nations and that is US and European Union accept that there is a technology called IoT, it will not come forward basically. So they accepted in the year 2005 and 2008. So IoT was officially born in the year 2008 to 2009. Keep that in mind. Okay, IoT started at that point of time, and officially we started getting books and all. A lot of documents came on that. Okay, but the question which arises now is, you are saying that that means everything should get connected to internet. That means we all know that today we are able to connect to internet. How we are able to connect it to internet? We are able to connect it to internet with the help of something called as an IP address. Am I right? IP address. So what IP address is nothing but an internet protocol, which is nothing but an address basically, a unique address. Your mobile will have, your desktop will have, your laptop will have, so and so, so that it recognizes you basically. It's a network address. But you are saying that everything should be connected to internet. That means everything should have a IP address. How is that possible? Because already that IPv4 which was there, which we are using, that is something 32-bit. 32-bit is already over. 2 power 32 is already obsolete. We have consumed it. But now you are saying that things should get connected to it. So the advantage what we had is in the year 2011, IPv6 launched this. Because of IPv6, I think you know that IPv6 is 128-bit. That means 2 power 128 addresses you can have. You know what is the power of 2 power 128? The power of what 2 power 128, what they say is every atom in this planet can get an IP address. Every atom in this planet can get an IP address. Apart from that, 100 plus Earths can get IP addresses. So atom is the smallest unit. So you see, every atom can get an IP address. That's what they're saying. So that is the power of IPv6. When IPv6 came into picture, then people started visualizing that IoT is going to come into the market now. That means everything can get connected to internet. So that is what. So then I think we all know there is something called hype cycle for emerging technology. Generally, there is a company called Gartner which makes this graph basically. So where they projected IoT for the first time in 2011 because of the launch of IPv6. Until then, IoT was in the back shelf only because they were not able to visualize because 32-bit was already over. How can I make everything get connected to internet now? So after the launch of IPv6, IoT came into picture into this graph. So then in 2014, IoT was at the peak. IoT was at the peak. I think we all know that IoT was at the peak even in our country also because in our country also they started something called Smart Cities Mission and so. But because they felt that IoT is the solution for all of this. So IoT was at the peak in the year 2014. Like that, things were happening over the years. And if you look at later now in 2018 and so, 2018 IoT platform, they are expecting that IoT platform is already there. Above that, people are planning to put something called, I think yesterday, I think someone has taken a session on neural networks basically. That means deep learning, what people call today, AI, ML, deep learning, and so. So that is what they're expecting is above the IoT platform, these things are there basically. They don't want any human intervention. It is the thing which should take a decision. So that is what they're planning basically. So that is what is expected now. The expectation is IoT platforms are already there. Above that, what you are going to build. Okay. Then in 2019, now the shape is people are expecting IoT billions of devices coming into market basically. But what is the technology for that? People are expecting 5G will take over all of them basically. Now 5G is at the peak now. We are expecting even 5G spectrum in India. So 5G The advantage with if you look at 3G, 4G and all, they never targeted IoT. They were only for audio, video, and so data basically. But 5G is targeting everything, high bandwidth applications and even low bandwidth applications like IoT. So because you can't have high bandwidth for IoT devices because IoT devices are constrained devices basically, and they're running on batteries. So 5G is targeting both high bandwidth and even low bandwidth, especially targeting IoT. So that is where we are in at this point of time. Okay. So this is what is a bit of history on IoT. Now let's get into the definition of IoT. So when I want to get into the definition of IoT, you may be saying, sir, what is their IoT? A simple definition, Internet of Things. That means everything should get connected to Internet. That is a very simple, but in a technical way, Mr. Kevin Ashton says like this. He says that IoT refers to uniquely identified objects and their virtual representations in an internet-like structure. So when I look at this, even it's tough reading it, but according to me or according to different scientists, what they say is Internet of Things basically. So what is that? Internet is there, things are also there. Okay, I'm right. The name internet is there, things are. What is internet? Internet is nothing but which follows standard protocols like TCP, UDP, and IP. What are things? Things are nothing but which have names like a pen, a bottle, a projector, a mic, and so basically. Am I right? They never had addresses. Am I right? They had only names. They never had addresses. So what they say is, Internet of Things is nothing but world wide web of things. World Wide Web of Things. World Wide Web of Things, which have unique addresses and which generally follow standard protocols like TCP, UDP, and IP. So that is what they call it as IoT basically. So this is the definition generally given for IoT. Okay, but a lot of people, as I clearly told you, that a lot of misconceptions are there because a lot of people have a lot of names, but they'll be having the vision is IoT only. So if you look at if you look at some people, they call it as M2M, that is machine to machine. Machine to machine is nothing but one machine talking to other machine and sending the data to the server. What is that? It's nothing but IoT. Some people call it as industrial internet. Some people call it as industry 4.0. So they're all nothing but industry should be fitted with IoT devices like sensors, actuators, and so basically. So that is what it is. In our country, we call it as smart cities basically. Smart cities, how is it possible? It's possible through these things getting connected over the internet basically. So different people have different names. Like Cisco, if you look at, they call it as Internet of Everything basically. So like that, but always remember that it is nothing but IoT only. Don't get concerned that people are working on different areas. They're all working towards IoT only. Always remember that. Okay. Um, mm. Now, what exactly is Internet of Things? When I talk about what exactly is Internet of Things, we need to see as engineers, we should know what are the components of an IoT. Okay. So when I look at what are the components of IoT, always remember that IoT is made up of three things, but there is a fourth thing. I'll tell you what is that. Generally, what happens is IoT is made up of sensors, connectivity, people, and the process. But there is a fourth hidden component which is called as an actuator basically. Fourth hidden component which is nothing but called as an actuator. So what is this actuator is which can take an action. It can take, but the problem is sensors, connectivity, people, and the process are a must for IoT. Are a must for IoT, but actuators it depends on application to application. So always remember that it depends on application to application. But sensors, connectivity, people, and the processor are a must. So I'll take up two examples where you have an actuator, where you don't have an actuator. A simple example, the first example I'll take up is the garbage bin. Today, a lot of people talk about a smart garbage bin. That means I'll put an IoT module inside a garbage bin where it will be able to sense the level, and based on that, it will be able to give the information to the garbage collector. So there will be a sensor there inside the garbage bin which senses the fill level, and through some connectivity like anything like it can be Bluetooth, it can be Wi-Fi, it can be 3G, 4G, or whatever we call. Through some connectivity, it will be sending to the people and the process. That means it will be sending to the server. On the server, it will be processed and sent to the respective garbage collector. Garbage collector are the people basically. So what do? They come and clear the garbage basically in the respective garbage bin. So here you have sensors, connectivity, people in the process, but there is no actuator. But I take up one more example basically where you take up any field, you want to monitor the crop. when you want to monitor the crop, a farmer wants to monitor the crop whether water is there or not. What he'll do, he'll put a soil moisture sensor inside the uh, soil moisture sensor inside the field. So when you want to put a soil moisture sensor inside the field, what happens is we'll put, the soil moisture sensor will sense the moisture level. Based on that, it will be sending to the server. On the server, what he'll that will be processed and sent to the farmer. And farmer, what he'll do is he'll be responding with the help of a mobile phone, telling that on the sprinklers. So sprinklers are the one which are acting as actuators, which will sprinkle the water and increase the moisture level basically. So here you need actuators, but in the previous application, you never needed actuator basically. So always remember that. Always remember, sensors, connectivity, people, and the processor are a must for any IoT application. And the actuators vary from application to application. Okay. So if we look at the components like sensors, mm, sensors. The thing is, sensors are nothing but which give us the input. Am I right? So depends on application to application. Any application you have, any application, whatever application you have, that data will be going to uh, the data will be taken as the input and it will be sent to the respective servers basically. For example, I want to know the temperature, I'll be putting the temperature sensor. I want to know the humidity, I'll be putting the humidity sensor. I want to know the pollution level, I'll be putting the gas sensors. So depending on the things, we'll be putting the respective sensors basically. So sensors are the input. So for any IoT solution, sensors, I would say sensors are the heart of any IoT solution because they are the one which are going to give you the input basically. Always remember that. Always remember. So the next component is connectivity. Connectivity plays a very major role. I think before starting off my session, I made a statement that at least we should have 5 to 6 years of battery life without manual intervention. So immediately sir asked what is this 5 to 6 years and all. So the whole life of a battery is managed by this connectivity only. So what connectivity you use that depends on the life of the battery. Always remember that. Very clear. Why? Because more the power, more the range. Less the power, less the range. So that is the issue basically. But IoT is looking at a different angle. What IoT is looking at a different angle is IoT is expecting something called as low power, low power, long range basically. Low power, long range. So it's against the physics, but what they're working, that is what I'm saying. See, we can't depend on the existing protocols. For IoT, we need to come out with something new protocols. That is what people are working on. So all these legacy protocols like your Wi-Fi, Bluetooth, and all really doesn't suit IoT. But people are still using them for different applications. But what people are talking at this point of time is something called LPWAN. LPWAN is nothing but low power wide area network. Low power wide area networks. That is what people are looking at this point of time. So keep that in mind now. So I'll be talking about LPWAN, not a worry. So a lot of new protocols are coming up basically for connectivity because especially power consumption is the major issue. Power consumption is a major issue. So these sort of things are coming up into the market. So connectivity plays a very major role in IoT because the data from the sensors have to go to the server. So how does it go to the server is connectivity plays a role there. Okay. Then we come to people in the process. When I talk about people in the process, as I clearly told you that finally someone has to use the data. So why we are collecting the data? Because we want the data for some particular applications basically. So the data once it comes to the server, it is processed, and depending on the data, it will go to the respective stakeholder. For example, agriculture data will go to the farmer. It will go to the agriculture scientist. Garbage information, it will go to the municipality and the garbage collector. Traffic information, it will go to the police. It will go to the different commuters. So that is how we need to look at basically. So IoT is majorly sensors, connectivity, people in the process. Always remember that. So, but that is at the top level. But when I decrypt it further, because we are all electronics engineers, we should know that it's not as simple that sensors will send the data to the server and all. So when I look at the different components, the top level, if you look at top view, the sensors, connectivity, people in the process. But when I strip down or decrypt it further, it will be sensors getting connected to a microcontroller, a low power microcontroller, or today we call it as ultra low power for IoT. Previously in embedded systems, we used to talk about low power. But when IoT came, people are talking about ultra low power basically. Very less power consumption. Whenever there is no work, it should get into deep sleep. So nowadays, controllers are giving us the different power options basically. like sleep, hibernation, and a lot of other ways, deep sleep, and all those things. So people are working on them basically now. So that is what we need to look at. The sensors have to be interfaced to a controller. The controller will process the data and send it to the cloud. But how does it send it to the cloud? On your sensor node, you should have a communication interface basically. Communication interface also plays a major role. So what sort of a communication interface you will use? Is it it depends on the range basically. Where is your server? So for example, a server is within my room, my sensors are within the same room. I can use Bluetooth or I can use Zigbee basically because they're all personal area networks basically. But my sensors are somewhere and my server is somewhere within my campus. I can use Wi-Fi. Generally, people do that because the range of Wi-Fi is within a campus. But once I am outside the campus, that means my cloud is somewhere else, my server is somewhere else, my sensors are somewhere in the field. Then people look at something called as like 3G, 4G, and 5G coming up basically. 3G, 4G, and 5G coming up. So what people have done is there are two architectures what people are looking at this point of time. Two architectures. So one is uh, because as I clearly told you that I need to give a battery life of 5 to 6 years and so. So what people are doing is the sensors will get because they are all running on a battery. The sensors will send the data to a gateway in the middle. Basically. Gateway is powered. It's connected to the mains. So gateway will be there somewhere in my campus. So these sensors will send the data to the gateway. Gateway will send it to the cloud because gateway is powered. So that is why a lot of people are using low power protocols here, low range protocols here. They send the data to the gateway from gateway to the cloud. If you don't want a gateway, you want to directly send to the cloud, you have to compromise on power basically. So that is what people are looking at two different architectures now. Gateway or without gateway. Always remember that. Then once the data comes to the cloud, on the cloud, you have a database where the data gets stored. It has to be processed, and you need a dashboard because today people are talking about dashboards basically, where you can visualize your data, like a temperature data or humidity data, all these data. People are looking at this point of time. Okay, so that is what. And finally, today people are, I think, even looking at the mobile applications. Basically, on the mobile, I want to look at all the data coming in basically because now they have added a new interface to IoT that is called as voice user interface. Today, I want Alexa to do everything basically. I'll tell Alexa, give me the temperature. It will send me the temperature. It will send me the temperature basically. Alexa will send me the temperature. I will say Google, give me this data. Google will do. So it's a new interface which is added to IoT today basically. New interface, what people are looking at. And finally, the data analytics is done. I think analytics is out of our context basically. So as an embedded engineer, here I should look till here because these are the different components I need to work on. Always remember that. Okay. Yeah. So just a small architecture because we are working on the smart cities this thing applications. So a bit of architecture which I put up for my. So just wanted to give you a glimpse so that you can have a clear picture basically. So generally always remember that any application you take up in IoT, any application, the architecture is basically the same. We'll have sensors, we'll have connectivity, people in the process, and depending on the application, you have actuator basically. Always remember that. Always remember that. So basically what happens is whenever first is the application requirements, then you have the based on the applications, you need to collect the sensors, what sort of sensors I need to put. Then you will have something called as IoT backbone basically. So this is what we need to talk about today. Today we need to discuss about these things only, sensors, IoT backbone, cloud framework, and all these things I need to talk about basically. So this plays a very major role, IoT backbone, always remember, because what sort of a device I need to put, what sort of a firmware I need to, do I need an operating system? So what are the standards I need and all these things basically. So finally the data once it comes to the cloud, what sort of a cloud I need to use? Can I use some prototyping clouds, some free clouds, or do I need to go with some paid clouds like your Microsoft Azure, AWS, and so Watson, IBM Watson, and so. So all these things I need to talk about. And finally, I'll be talking about the services. I'll be talking about the services. Finally, because they'll be visualized as different services basically. And finally, there is something called a visualization component, which I told is nothing but the dashboard. So always remember that these components make your IoT system basically. So we seriously don't think about like this, but we need to look at the complete architecture, something like this. Basically. Okay. So so this is how, and now as I clearly told you that based on all these applications, Based on all these applications, based on all these sensors, connectivity, people in the process, there are n number of applications in the market. A number of applications in the market. But the thing is, I think I'll be explaining about some applications today so that you'll get a clear picture of what is the role of a sensor, what is the role of connectivity, what is the role of people in the process. Okay, so just keep that in mind. So many applications are there to take up any domain in the market. Any domain in the market today, IoT is playing a role basically. We can't tell that one domain where IoT is not playing a role. You take up home, IoT, lot of applications are there. You take up transportation, IoT applications are there. You take up health. Today, I think a lot of people are wearing wearables sort of a thing today. Am I right or wrong? So health also IoT is playing a role. Where that wearable is talking to your mobile phone. On your mobile phone, you are able to see your what is your heart rate, what is your pulse rate, what is your BP, and so. So in the buildings today, we take up a lot of flyovers coming up and all. They're putting up sensors to see what is the vibrations, what is the load test, and all those things basically. Cities, lot of applications, as I clearly told you that, like smart lights, smart signage, waste management. So many applications are coming up based on IoT basically. So I think that is why today, if you look at IoT, has become a trending and buzzing topic today. So like that, if you look at so many applications are there, and if you look at IoT applications popularity, when as I clearly told you that IoT was at the peak in the year 2014. So in the area, if you look at some applications where IoT was playing a major role was a smart home, because as I clearly told, so many applications are there in smart home today. I think smartness has increased in our home. Everything we wanted to just do it through our mobile phone or do it through your voice and all. So if you look at, and even if you look at agriculture was also playing a role in IoT. So agriculture was also there in the top 10 applications basically. So wearables were number two, smart city was number three, and so in 2014, if you look at. By the year 2015, wearables have increased because a lot of people, everyone wanted to have a watch which can detect what is their BP, what is their pulse rate, and so. So like that, the ranking was there for different applications. So if you look at industry segments, connected industry, yes, connected industry was there for IoT, or that was the number one industry because a lot of vehicles. Yeah. So So a lot of, I think I don't want to get into a lot of these things now. So let's get into the, see if you look at there is a periodic table for IoT also. There was a periodic table. This periodic table generally changes every year. So the thing is they made a periodic table putting up different like domains. What are the products available in domain? Like for example, the first one is wearable domain. What are the products available? In the orange domain, what are the home applications basically? In the pink, there were what are the building blocks or platforms? Then blue is connected cars. So many applications are there. Basically. This table changes every year based on the applications coming up into the market. So that's how you can see how we're trending and buzzing IoT is today in the market basically. So if you look at all these things, yeah. So let me get into now some examples for you guys so that you get a clear picture of what is happening in the market today. So first, what we'll do is I have divided this into different domains. Like first is health, that is our body. We'll see some one or two applications on our body. Then second thing, what we'll do is we'll look at our home, some applications. Then our what we call our city, then environment, then environment, and then so on basically, and then we'll get into the technology. Okay, so let me start off with my body. So what do you mean by body? IoT for my body. I mean IoT for my body is I want to put sensors on my body, right or wrong? Sensors on my body so that it can detect what is happening in my body. So that is where they say IoT for our body basically. So the first application I'll be talking about is something called MIMO. MIMO is an application, I think one of the famous application or famous product I would say. It's so as I clearly told you that generally if there is a problem statement, then you'll convert that problem statement into a solution basically. Am I right? So what is the problem statement here? The problem statement for this small product which is there here, if you look at this is what is called a MIMO device, basically a small device with sensors inside it and connectivity also. So people may ask, what is the problem statement? The problem statement is infants at the age of 6 months, 6 months. So they are generally uh, infants at the age of 6 months. What is generally happening is they are dying while sleeping basically. So it is generally due to something called as SIDS, sudden infant death syndrome it is called. So what is this SIDS is even doctors are unable to understand what is happening. Then they realized over a history telling that if infants are properly monitored, then there can be a solution for this. So when infants are properly monitored, then they thought, can IoT solve this? Because if we put sensors on the body of a baby and if they can be really monitored in real time, I think they can be the seeds can be prevented. It can't be cured basically, but it can be prevented basically. So what they did is they pushed up some sensors like uh, baby's breathing, skin temperature, body position, and activity level in the small device basically. And the connectivity is Bluetooth. So these are the sensors which are there, and the connectivity is Bluetooth, and it is going to the mother's mobile phone. So on the mother's mobile phone, it will be triggering, telling that your baby woke up, go and feed him or feed him and feed her. So and baby's temperature is high, take him to a doctor. Or a baby woke up, do whatever is the things basically. So based on these parameters, uh, they were able to uh, uh, understand the situation and solve the issue basically. So that is why this small product is playing a very major role in especially developed countries like US and UK and so very heavily being used. See, if you look at this product, it had sensors, it had connectivity, it had people in the process, like the mother or a caretaker basically. So it was like a win-win situation for both mother and the child. So that is how this is one IoT product I would say. The second IoT product, especially targeting our health, is it is called Vitality. Vitality is a company which has designed a small bottle called as a glow cap. So what is this glow cap? Is glow cap? I would say that it's a pill bottle basically. You need to put up some pills. So what this cap which is there, it has something called a load cell. That is, load cell is nothing but a uh, weight sensor, and it has a tilt sensor also. So that whenever whenever you are taking medicines and all those things, it will have a clear picture of this thing. So what generally happens is, you all know that generally any patient like a BP patient or a diabetic patient, they generally have a tendency of uh, continuously taking medicines, like morning before breakfast, after lunch, or after dinner. They have to continuously take medication basically. So this bottle reminds them of when they have to take a medicine. When they have to take a medicine, but the problem is, you may be questioning that why is this solution required, sir? When my mobile phone can have an alarm, I can put an alarm and I can remember that when to take a medicine. But as I clearly told you that this has something called as a load cell, that is a weight sensor. So whenever the medicines are getting reduced, it will trigger the nearest pharmacy so that he can come and refill it. And apart from that, in this cap, there is a connectivity GSM. So it will be going to the respective doctor that what is the log of this guy, whether he's taking the medication properly or not. So all those things are there in this. So that is the advantage with this sort of a device basically. So especially targeting people who are on medication. Okay. So this is one application about my body. Then getting into our home, the first question comes is, why do we need IoT for my home? So a lot of people see. I would say that I need IoT for my home to make me lazy basically. All right. But really, that is not the case. A lot of people are using it for a different cases basically. A lot of people say that we can remotely monitor our house. And apart from that, they say that gadgets or other these things are unnecessarily being switched on. So because of these IoT devices, I can have a complete picture of what is happening. So it is reducing my monthly bill and resource usage also. Indirectly, we are saving ourselves and we are saving the nation also. Resource usage is completely getting reduced because of this. Or not simply will be wasting these things, keeping them on. So that is what people are talking about with the help of IoT. Mm, So what happens is, so the thing is, if you look at the first product I would talk about is it's called as a Google Nest. It's from it was a Nest was a company. Later on, Google has taken it over now. Recently, I think last 2 years or 3 years back, they have taken over this company. So the thing is, if you look at what is this Google Nest is nothing but a smart thermostat. Thermostat is nothing but which controls basically, right? Which controls the temperature thermostat. So this guy also does the same thing. So um, so it will have a complete your gadgets will be completely connected to this, and it will be completely controlling them basically. It will be completely controlling them like your ACs, geysers, and all those things. So if you look at previously, uh, it was complete manual where you have to feed when the temperature should be like this, when the temperature should be high, low, and all. But now, as I clearly told you, that IoT platform is already set. Above that, people are expecting something called as a deep learning or machine learning, which is there. So now the recent devices which are there are basically completely based on this deep learning, where they take decisions basically when to keep the temperature high, when to keep the temperature on, when to on your cameras. So, and one more thing is it will have a complete geofence of your house basically. So it will be tagged to your mobile phone. Once I'm out of my house, it will give a complete picture of my house. So what are on, what are off, and all those things. Once I am coming towards the house, it will say that you're coming towards the house. Do you want me to switch on the lights? And all these things, it will be pinging you. So lot of good products of IoT are there in the market today, basically. So this is one best example I would give. The second example I'll be talking about is something called as mm, Belkin Vimo. Uh, um, so Belkin Vimo is, I think, it's like a smart plug. So you can connect your gadgets to the smart plug basically. So whatever gadgets you're connected to, you can wirelessly, remotely, anywhere, any place, you can observe them. Okay, anywhere, any place you can see them, just like on your mobile app. So what are the appliances which are on? You can remotely see them. So it's nothing but a small router sort of a thing. Just like you have routers in your house, will have this sort of plugs which are there basically. Okay. I think Amazon Echo, I think we all know about this product. I think it added a VUI. As I clearly told you that now recently everything is based on VUI basically, voice user interface. So this Alexa added to that. Alexa added to that. You can just voice over, you can tell, and it will take action based on that basically. If you want to switch on the lights, switch off the lights. You want to book a cab, you want to book a pizza and all. Everything it will take care basically. So that is why this is called Amazon Echo. It's a very good product available in the market today. I think heavily being used in India also today. Okay. So this is one example I would give. And there is something called Amazon Go. Amazon Go, I think I don't want to get into much details of this because Amazon has gone ahead now. Because what people are talking about is IoT platform is already there. But above that, what is the thing? So today people are talking about not one sensor or two sensors talking. People are talking about something called sensor fusion today. So multiple sensors talking to each other and taking a decision. So, and people are talking about something called as the computer vision. Sensor fusion, computer vision, I think these two things are playing a very big role in this basically. Here also, if you look at in Amazon Go, you have to just enter, take your mobile phone. There won't be anyone. You have to just pick up your basket and push the things and just come out. Everything will be taken care by your mobile phone basically. So whatever you are pushing and all, it will be creating a virtual cart basically. Virtual cart into your account. So based on that, it will be taken care. So that is how we need to look at how things are happening basically. Okay, so this is, I think this is already implemented in two cities in America. I think slowly it will push on to all the places. But the biggest problem is, I think people are losing jobs because of this. Because everything is getting all, because of computer vision, sensor fusion and all, less manual thing is happening there basically. So that is what we need to learn. Then I'll be talking about one application which is for our city. City, I think city, whenever I'm talking about IoT for my city, so the best thing would be is clean and green environment. Am I right? So the first thing I'll be looking at is clean and green environment. When I'm talking about clean and green environment, what is that I need to look at? Um, clean and green environment. What is that I'll be looking at is something something like a sensor, like a garbage bin, or so we'll be talking about. So the first application I'll be talking about is a garbage bin application. So if you I think I'll be talking about our application so that that will give a clear picture of what is happening. So the application which I'll be talking about is something which we have developed so that you'll get a clear picture of what is happening. So that is it's called as a Garbo. That is Garbo is nothing but a garbage zero basically. So it's a smart garbage bin application. I'll just give you a glimpse of what we have done. Okay. so that you will get a clear picture of what is happening. So the thing is, as I clearly told you that any architecture you take up, it is pretty simple: sensors, connectivity, people, and the person. If we look at the same thing is the garbage bin is the sensors. So what are the sensors we need to put? So the sensors we need to put is, as I clearly told you, that level detection sensor is one. And apart from that, we got a requirement from our municipality where they said we need to put even what's in like a foul smell sensor, because foul smell also is like apart from fill level, that is creating a bad smell throughout the society basically. So these are the two different sensors what they have suggested. And apart from that, one more sensor they suggested was uh, sometimes in the garbage bin people put fire and all. So that is also an issue basically. So can we put up some other sensor like the fire sensor also? So these were the three sensors which we had to look at when we were collecting the application requirements. Okay. So and wireless interface to the cloud. Wireless interface to the cloud, as I'm telling, that the data has to go to the cloud. When the data has to go to the cloud, uh, so what should be the connectivity? Connectivity, that's a fishy thing basically, because garbage bins are put outside. So the cloud will be somewhere else. Municipality office will be somewhere else, and garbage bins will be somewhere outside. So what is the connectivity I need to give? If I use 3G, 4G, it will kill away the power. Am I right? 3G, 4G, it will be killing the power. So I can't use Bluetooth because the range is very less. I can't use what you call Zigbee. The range is very less. I can only go with even Wi-Fi is also, if you look at the range, is within the campus basically. But garbage bins are somewhere lying outside, and the server will be somewhere else. So what is the solution for that? So that is why people are working at, as I clearly told you, that something that initially we also started with the 4G, but later we realized that we are not even able to get up to 4 days of battery life when we are using 4G basically. So we shifted to something new protocol which is called as an LP-WAN protocol. It's called as LoRa basically. That is nothing but long range. I think you guys might have heard about LoRa by now. A lot of new protocols are coming like LoRa, NB-IoT, RPNA, and so basically. I think I'll be talking about them. Don't worry. So finally, the data from here has to go to the cloud. On the cloud, what happens is a different process will be running. One is the routing analytics basically. Analytics is nothing but so where are the garbage bins where the garbage has to be collected. So based on that, I'll create an optimized path for him so that he reduces his fuel also. So that is also I need to keep in mind basically. And finally, the data. Finally, the data has to go to the mobile applications. Finally, the data has to go to the mobile application of the garbage collector. On the garbage collector, when he opens his tab or a mobile phone, he'll get a complete path where he has to go and collect it. And apart from that, we have added one more component which is called as the crowdsourcing. Because as I clearly told you that see, IoT is based on completely sensors and all. Sensors may work or may not work. But even if we include crowdsourcing, that is people giving information, so that will add a added value to your solution basically. So any issue is there, we have put up even people also can scan and send the information to the server basically. So that is the complete architecture what we have for the garbage bin. So if you look at, so now the thing is always remember that any, because with my, what you will say, with my experience, I'm telling you that always remember that any smart city application you are doing, people expect you to do something called retrofitting. Retrofitting. You shouldn't go and tell him that, sir, this is my garbage module. It will work only with my garbage business. No one will take your solution. You should your garbage module should be in solution that already lot of governments, lot of cities are having garbage bins. You should be able to retrofit them into that. Then only any government will accept it. No government will accept to buy completely new garbage bin. Always remember that. So we had different models to work with. So that is why we need to look at what is the proposed solution. Are we coming out with a complete garbage bin with the module, or we need to retrofit this into the existing garbage bin? So that is what I was just looking at, and finally we felt that we need to retrofit. We can't build a complete garbage bin. Always remember that. Okay. And apart from that, one more thing is one thing I want to tell is any IoT solution is possible. I always say this: any IoT solution possible if people adopt it and adapt it. That means a simple example I'll give is the garbage bin. See, my module will work if you put garbage inside the garbage bin. If you put garbage outside the garbage bin, any IoT module will work. No IoT module can work for that. Am I right or wrong? So that is what we need to have public awareness into the picture of any IoT solution basically. So always keep that in mind. So keeping that in mind, we have developed this small module basically. This was the first prototype. This is not a product. This was a prototype. Always remember, there's a lot of variation between the prototype and the product. Prototype is to it's a proof of concept. That means the solution is working. For a product, a lot of things change basically because you need to put them outside. So you need to look at all the external environment protection boxes and all of things. So this was the first prototype what we developed basically. First prototype what we developed. So this had ultrasonic sensors, foul smell sensors, and temperature sensors. And apart from that, if you look at the controller which we use is initially we started with ARM7 DMI. Later now currently we are moving to Cortex M0 Plus basically. M3, M4 is also there, but the M0 Plus we felt is suitable for this because it was ultra low power. And initially we tested with GSM, that is 4G with a 4G SIM card. But as I clearly told you that we could hardly get a battery life of 4 days, not more than that. I think simple, you only tell me in your mobile phone, how many days your battery lasts when you use 4G, Wi-Fi, Bluetooth and all continuously. Hardly a day and a half and so on. But your mobile phones you are able to recharge. But what about this garbage module? After fitting those modules inside the garbage bin, any engineer will dare to go and remove it. See the condition of our garbage bins. I think that's what we need to put efforts before only. That is what I want to say. The developer should put efforts before so that I need not change the battery at least for 1 year or 2 year or 3 year whatever. So then only anyone will be willing to take it. You can't say and tell the garbage that is the municipality that every month I need to change the battery. No one will take it. So you need to put efforts there basically in your solution. So when I'm putting the efforts in my solution, then mm, so LoRa, mm, um, so LoRa was a technology which currently we are using for the product. But initially we tested with the 4G for proving the concept. But later on, we are moving towards LoRa today now. Okay. Then IP66 protection is a must. Whenever any device is going out in external environment, you need to have protection levels basically. It's called ingress protection XX. One is levels of dust and levels of water basically. So now whatever box we are using, so it is having 6 levels of protection from water, 6 levels of protection from dust basically. Always remember that. You have to choose. I think in the latest, I think your mobile phones, I think Apple or Android, I don't remember. They say that you put it in the swimming pool, it still works. Why is that? You see backside, it will be certified IP67 or IP66 basically. Something like that will be there. You can check it. That means it is the box is protected from water and dust basically. Okay. Then comes the power. So what sort of a power we need to use? So what sort of a power we need to use? The power, as I clearly told you that power is one is battery or solar basically. Solar because you can store the energy and use it basically. But one thing you say that can you predict that the garbage bins will not be put under a tree or a shade? If it is put, solar will not work. Then what to do? What to do? That is why always go for a generic solution that is with lithium battery also. So even lithium batteries also nowadays there is a better batteries which have come which promise around 10 years of battery life. Which is called lithium thionyl chloride basically. Lithium thionyl chloride. I think I'll show you that battery once so that you'll get a clear picture basically. So they are promising around 10 years of battery life. So that is what we are looking at. Okay. So these are the different specifications. So initially for prototyping and all, we use this board basically. So we didn't directly jump into developing a product. First we thought let us test it, then let us develop a prototype, and then jump to a product basically. So initially we taken a development board, we pushed our sensors onto it basically. So this is the Linkit One development board, which is having ARM7 TDMI, and the advantage it had was internal to the board only we had Wi-Fi, Bluetooth, and GSM basically. So whatever application you develop, you can choose whether I want a personal area network, I can use Bluetooth. If I want a local area network, I can use Wi-Fi. If I want a wide area network, I can use 4G basically. So this is one of the versatile board which is available in the market, which is from MediaTek. So I have used this. I push the sensors onto it. So then if you look at this was the complete module which we have developed. This was the first prototype. This included the battery, and
Huh?
it was this is the.
Huh? 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 Huh?
Yeah. So there was an ultrasonic sensor, and there was a temperature sensor. Initially for testing, we used this, and this was the box. This is a general normal plastic box only. It is not IP protected box, so which we could do by 3D printing in our office. So we were able to do this just for developing the prototype. Okay, prototype. So we tested that in various bits, pushed up in the various. See, as I clearly told you that the life of this was not even 4 days. So we had to put a power bank also. Power bank because we were using 4G at that point of time initially. Uh, Now later on we moved to this first version. This is IP protected box. Basically, it's a complete IP protected box, and this is the ultrasonic sensor. So now the question comes is, what is this ultrasonic sensor? Is of the shape of a cone. Shape of a cone. I think see that is what I say. Everything works in the lab. Every everything works in the lab, but everything works in the lab. But the problem is when you go to the field, a lot of things don't work because what happens? Your temperature plays a role, humidity plays a role, uh, wind plays a role, everything plays a water plays a role. All these things play their own role basically. So for protecting them and all. So what happens is, and apart from that, always remember that. See, when you take up a garbage bin. See this ultrasonic sensor. What is the formula of ultrasonic sensor? Ultrasonic sensor works on sound waves, am I right? It sends the sound waves. When it sends and it return back, am I right? You get an echo back basically. When you get an echo back, it will calculate the distance and the time. And based on it, it will tell the fill level is 70% or 80% or 50%. But ultrasonic sensor works very good for flat surfaces. Ultrasonic sensors work for a flat surface. But uh, what will happen now when there are irregular surfaces? Because if you look at garbage bins and all, they're completely irregular surfaces. When they are irregular surfaces, the ultrasonic sensor really doesn't work well because these are all wide beam sensors. That is why what these people have done is they have come out with a sensor called a narrow beam sensor. Basically. So when you send a narrow beam, it directly hits the target and comes back quickly. So that is why we have gone for this cone. All this you will understand when you test it in real time. See, but the problem is always we do like we test it in the lab and we feel that everything works. It's not like that. Okay. So that is what we need to keep in picture. We need to look at each and everything. Basically. Look at each and everything. So we need to always keep that in mind. So then if you look at the final product, if you look at it's something like this, our garbage in product. So this is completely IP67 box. So with the respective sensor and the respective communication, which we are using is LoRa basically. So this is the battery which we are using basically. It's called as lithium thionyl chloride. So it is a new variant which is coming up in the market because generally if you use your lithium and all, uh, so lithium, the power consumption with normal lithium batteries and all, they are all just like your mobile phones. Mobile phones, if you use or don't use, also power consumption will be there. But these batteries, what they're coming up into the market is they are saying so based on your consumption and all, see if you're consuming too much, this battery also may die within a day or two. But based on the consumption, that's what you need to write an architecture in such a way like that. So it will give a maximum life basically. So now currently the application what we are developed under this garbage bin. So we are able to get around 18 months of battery life basically with this. 18 months we are able to get because with the code, with the number of samples daily it has to send to the server and all. So up to 18 months we are able to give. That is almost almost 1.5 year we are able to manage with this basically. So that is how we are doing it. But overall life of this battery is what they say is 10 years. Always keep that in mind. Okay. So this is the mobile app what we have developed. As I clearly told you that we need an application also. We need a mobile app for the thing. So so the thing is this is how and this is how the garbage collector gets the path. Garbage collector gets the path for these things. So you need to always keep that in mind. Okay. Garbage collector. So garbage collector will go to the respective web bin and collect the garbage basically. So this is the complete app what we have developed. Okay. So this is the cloud. Initially, as I clearly told you that we need to have a dashboard so that see you can't expect a municipal commissioner or anyone to go to the field and see your garbage module, right? So you need to have a dashboard. So for having a dashboard, initially for testing purpose and all, we used a prototype dashboard, which was free for up to 10 devices. This dashboard is free, which is called as the MediaTek Cloud Sandbox. MediaTek Cloud Sandbox. So here we are able to very easy to configure this cloud. I think I'll show you tomorrow in my next session how to configure this so that you can directly do it basically. So we have pushed up all the data onto this cloud basically like this. So this is our first prototype what we developed. That is a garbage bin prototype. Okay. Yeah. So this is the first application. So there are a lot of applications. I think if you look at there is something called array of things which is coming up in Hyderabad. I think um, this is one I would say that an high-end IoT application is high-end. Why I call it as high-end is because this is not low-end, which is running on battery. This is high-end because this is having around 30 sensors inside this. This is a module. It is called array of things. That means around 30 sensors they are planning to put up in the different junctions of Hyderabad. So these things, if you look at, it consists of environmental sensors, air quality sensors, cameras are there. Two cameras are there, one bottom and one at the top. Bottom is for surveillance, top is for weather management, light and infrared sensors, and so on basically. So all this data will be sent to an open cloud where different departments can collect their own data basically. For example, pollution department can collect its pollution data, uh, mm, and different police can collect their surveillance data, weather department can collect their weather data, and so basically a single device for all in one purpose. That is why this is called array of things, which in Hyderabad they're planning to put. I think it was supposed to be put by now only, but I think they're taking some time to push this. Around 50 units they're planning to push in different junctions of Hyderabad basically. Okay, so this is one application I would love to tell. And now getting into industry, I think too many applications. I think we need to look at. I think as clearly told you that people are talking about something called as Industry 4.0 today. I think we shouldn't get confused because Industry 4.0 is nothing but industrial Internet of Things, because different nations have different names. So the version which industry revolution, what they're planning, the policy, what they're planning to bring is called as IoT should be there in every industrial equipment. IoT should be there. That is sensors, connectivity, people, and the process. Because as they clearly saying that you all know that all this machinery and all they cost a lot in crores. So well in advance, if they are properly maintained with the help of the sensors and all, they say that the cost can be reduced. So that is what they're bringing IoT into these solutions basically. IoT into these solutions. So I think a lot of applications are there. Let me talk about one more application which we have developed is regarding agriculture basically, so that you will get a clear picture of what is happening. Uh, So the product or solution what we have developed on IoT is something called as Harita Priya, we call it as. So that is nothing but precision technology for agriculture. So this was one project which was funded to us by government of Andhra Pradesh. So I'll be telling is, so the thing is, as I clearly told you that we need to have a problem statement. So what is the problem statement for IoT for agriculture? The problem statement is pest and disease forewarning, because every farmer generally he puts pesticide and all. When does he do that? When does he do that is uh, so when does he do that is generally what happens when the pest or a disease attacks the crop basically. So almost if the 30 or 40% of the crop is gone, then only he sprays it to protect the remaining 70%. Right. So, but we thought, can IoT give a solution at least 1 week or 10 days before only, before the pest or disease starts piling up, then if we can do something basically. So, but generally always remember there is a small formula that all these are due to climatic parameter only. So that is the advantage we got, because any pest or disease is based on climatic parameters. Climatic parameters means like temperature, humidity, leaf wetness, soil moisture, wind, all these play a major role basically. All these play a very major role in deciding whether a pest or disease is getting attacked. So we thought, why don't we put some sensors based on this so that we can help the farmer, so that we can forewarn him uh, whether a pest or a disease is getting attacked. But one more disclaimer here is, always remember that every crop will not have the same pest or disease basically. Different crops will have different ones, just like us. Every person can't have a same disease, right? Different people will have different problems basically. In the same way, brinjal may have a different problem, tomato may have a different problem, rice may have a different problem, wheat may have a different problem. So the thing is, sensors vary based on that. But finally, if you look at all these climatic parameters play a role basically. That we need to keep in mind. That always we need to keep in mind. Okay. So the thing is, so what we did is we wanted to develop an end-to-end solution to give advice to the farmers basically. In that we developed these three things. One is wireless sensor network. Wireless sensor network is nothing but what is wireless sensor network is nothing but IoT. Wireless sensor network is nothing but IoT only, Internet of Things only. If you look at here also, sensors wirelessly forming a network, sending to the server. So a lot of people, that's what even wireless sensor networks is nothing but IoT basically today if you look at. So wireless sensor network, that means sensors have to be put into the agriculture farm to get the parameters of the farm basically. Then decision support models. I'm clearly telling you that every crop will have its own formula. That means these decision support models should be given by domain experts like agriculture scientists. Like, for example, temperature greater than 35, uh, humidity is around 90, then rice is going to get an attack. Or for wheat, temperature less than 30 degrees, humidity more than 90. So wheat may get attack. So all these models will be running on our server basically. So the data input is given by the sensors. It goes to the server. On the server, these decision support models run. When the parameters are above the threshold, it will go as personalized agro advice to the farmer. Always remember that. So this is the solution basically. Here also you have sensors, connectivity, people, and the process. So this was one. So for that, what we have done is we have used as I clearly told you that you can have a standalone model, or you can have a what you call a gateway model, basically, gateway in the middle. So we used a gateway in the middle basically because at that point of time we had only Zigbee as our communication, so we had to use gateway in the middle. Then we had web technologies because on the web the data will come, so they have to play a role. And finally, the mobile communication. So if you look at the complete picture, the architecture is pretty the same. Sensors in the field, there will be a gateway. Sensors send the data to the gateway, from the gateway to the cloud. On the cloud, it will be processed and given to the respective people, stakeholders, like agriculture scientists, farmers, and okay. So in this project, what we have done is the agriculture scientists suggested us to put up five sensors. One is temperature, relative humidity, leaf wetness, soil moisture, soil temperature. So we have put up these five sensors. And for power, because they are all open fields, we have used solar. That was the best option we could get. Okay. So these are the units which we put up in the field so that you get a clear picture basically. So this is the complete unit. This is the WSN unit, this is the communication unit, and this is the sensing unit. If you look at communication unit with a solar panel and a Zigbee as a communication basically. Zigbee, and this is the sensing unit basically. So yeah, this is the sensing unit. Sensing. So you may be saying that the thing is, what is this? This is called as a gill radiation. See, generally what happens is your temperature and relative humidity will be inside this. Because always remember that temperature and relative humidity shouldn't be directly exposed to sun. If you're exposing them, your temperature it will show as 65 degrees or 70 degrees or 80 degrees. Do you really think that that much temperature is there? That much temperature will never be there. So generally what these people follow is they put it in something called as Stevenson's box. Like the temperature which is shown in your TV, na, minimum temperature and maximum temperature. These thermometers are put in some Stevenson's box which has ventilators basically. So air will be flowing through them. Then you get the correct temperature. So we also use that called as a gill radiation. Temperature and relative humidity will be inside this. And the leaf wetness is there. Now you may be questioning, sir, what is this leaf wetness sensor? See, I need the wetness of a leaf. So based on the wetness, moisture level on the leaf, I know that whether a pest or a disease is going to attack. But the problem is leaf can't give me data. No? How can leaf give me data? So we have replicated a leaf basically, an electronic leaf. So we have designed on our own, we have put it up. So whenever water falls onto this also, the same like water falling onto the normal leaf basically. So this gives data, leaf wetness sensor. So it used to give us the data basically. Okay. So these are the sensors we pushed, and so the thing is, I think I'll get into the thing what so the gateway and all. So finally, these were the this was the leaf wetness index model and GDD model, that is growing degree day model. So these are the two things which we were able to eradicate, prevent basically. Prevent in the sense we used to forewarn the farmer, telling that these two may get attacked and these two may attack the crop. So this is done. So through this we are able to develop a solution basically. So very simple formula. Nodes, WSN nodes will sense the microclimate, send it to the gateway. Gateway sends it to the server. Server will run the decision support model based on the input, and finally send the alerts to the farmer. Four-step formula. Simple formula. Okay. So this is how these are the places where we put up basically this project. We put up around 74 WSN nodes in 5 villages, covering around 450 acres. From 160 around 160 farmers registered basically. I'll just show you. So this is our dashboard. As I clearly told you that you show it to anyone. Today people are expecting dashboards. Always remember that. So this is our dashboard. So when you look at the dashboard, when you get into the individual node, individual village, you get the complete picture basically. So benefit, like how many farmers are there, what is the crop, what is the coverage area, how many are deployed, what are the sensors and so. So when you click onto that, it's a complete update. So when you go to a particular node in that village, you'll get the complete picture basically. What is the temperature, what is the humidity, soil moisture, soil temperature, leaf wetness, and all these things. Okay. So finally, the complete setup what we have used, was used for various purposes by agriculture department also. Is not only for WSN alerts, apart from that, for general advisories like government schemes and all, is to push through this interface basically. So it has become a complete end-to-end solution for agriculture department. So like this is how it comes basically. For a particular farmer like P. Srinivasulu. So this is a climate is conducive for leaf outbreak in 7 days. That means in next 7 days, his crop is going to get affected. So immediately that intimation will go to P. Srinivasulu, where he. So that too because we have to do it in local language, that is Telugu. We have to send like this. So these are all our engineers who are doing their job basically at the field. So we pushed up all these things set up and so this is the complete picture basically. Okay. So this is one application, as I clearly told you, case study, I would say, that which we have executed at CDAC basically. So like that, we are executing one more project. I think whenever time permits, I may explain this, but now at this point of time, please excuse me because this can't get in detail. This is what we call it as V2X, that is a vehicle to everything. So now people are talking about something called one vehicle talking to other vehicle, one vehicle talking to the infrastructure and so. So vehicles are also things basically. They're talking to the internet. So this is generally called as Internet of Vehicles, what we call as. So that is a lot of applications are coming up into the market. So we are also developing some solutions for this. So vehicles talking to each other, vehicles talking to the infrastructure, and all these things basically. So that is what now people are talking about CV2X basically, cellular vehicle to everything. So because 5G coming up now, a lot of people are working onto that now. CV2X we call it as. We're also moving towards CV2X now. Okay. So this is one application I would talk about. Oh, sorry. I think this I'll explain it next time. Please don't mind that. So just excuse me for this, and so that I'll give you a clear picture of what is happening basically. So yeah, just a minute. Okay. So a lot of applications are there. I think I don't want to get into all these applications. I think I'll share my presentation so that you can do it, and I'll end these applications with one application that is nothing but IoT is even into sports basically. So if you look at this is a small sensor which it's developed by a company called Specular. It's an Indian-based startup company basically that we should appreciate. So this unit is called as BatSense. So it's sensing what is happening when a player is playing basically. When a batsman is playing, it will sense basically. So one more thing is one best component I would say is previously all the products which I have shown you are completely based on ARM architecture, that is ARM architecture. But this is a small unit which is based on Intel architecture basically. Because just to give you a glimpse that even Intel is getting into IoT because they are seeing 50 billion devices into the market. Because Intel is already into servers, desktops, laptops, and all. But now they want to get into embedded market also, so that number of devices are more in this. So that is what they are competing with ARM on this. But ARM is way ahead of Intel. Always remember that way ahead of Intel. So this is a small unit basically. So it's put in the handle of the bat so that whenever a batsman is playing a particular shot, it will clearly give him a picture that what is happening. So how does this work is sensors are put in the handle of the bat in this way. the handle they're putting the sensors. This you may say that the weight of the bat may vary. So they are saying that the unit is less than 25 grams, less than 25 grams. So this has a accelerometer and a gyrometer, and it has the Bluetooth as its communication basically. Sensors have accelerometer and gyroscope. Bluetooth is the connectivity, and people and process. We all know that on the server, once the data comes, it will process and show the batsman that whether he has played the right shot or not. Okay, so this is one thing which is heavily being used in the market today. Okay, yeah. So a lot of applications, defense also, a lot of applications are there. So if you look at IoT proliferation, any domain you take up today, it's everywhere, basically everywhere. I think we need not name. I think looking at this diagram itself, we can see the complete proliferation of IoT today. Proliferation of IoT today. So that is what I would say that IoT is going like a buzzing and trending topic today, basically. Okay, so the thing is, now I have to get into the technology component. I think in the next session, I'll take care of the technology component. I think I'll stop here with the case studies so that in the next component, we can look at the hands-on approach and technology, basically. All both together, basically. Okay. Thank you, guys. Any questions, I'll be able to answer, basically. I think I could, I think one question I could see is what is the difference between the IoT and the sensor commercial enterprise? I don't know. Sensor commercial enterprise, what do you mean by that? I don't know exactly. Sensor commercial enterprise. I really don't know. Sensor commercial enterprise because never heard about it. Any other questions you have? Sir, I'm done for today's session, sir. Hello. Hello. Hello.
Hello.
Sir, hello. Yeah. Hello.
Yes, Dr. Srikanth. Yes.
Yeah, yeah, please.
Nicely covered this topic.
Yeah,
Thank you very much. So we can
welcome.
invite some queries, questions, participants.
Yeah, that's what.
Hello.
Yeah, 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 I'm there, sir. I'm there.
Hello.
Hello, hello,
Yes.
hello.
My one this
Yeah,
one curiosity is there. A few days
yeah, please,
before,
please. Hmm.
Union Minister Gadkari ji was addressing to one of the house,
Yeah,
and there he mentioned wise
huh.
that we are thinking of a driver drive the vehicle and he's under influence of some intoxicants, the vehicle will not move.
Hmm. Hmm.
If
Yeah, yeah, yeah,
is under alcohols or some intoxicants, and the
yeah,
driver
yeah. Hmm.
run. So we're designing that of this. That means that they will put some sensor, some connectivity.
Exactly, sir. They'll be putting alcohol sensor inside that, or
Hello.
no, no, not only alcohol sensor, sir.
Yeah.
Nowadays they're planning to put up a camera based on his eye movements and all. Also, they're planning to do that basically. So if it is a drowsy or is not only alcohol, if he is having not proper sleep, is tired or something, also the vehicle may stop in the middle. That is what people are planning basically. Yes, that is true. Even I heard about it, sir. Yeah, yeah. That is with the sensors, computer vision, and this thing. What do you call AML? Yeah, that is true.
And even if the driver is not wearing the belt, the information
Mm.
will go to the near
Yeah, yeah. Mm.
is there. His vehicle at such and such highway, and he's not wearing the belt. That information he touched upon.
Mm.
That information will also nearest police stations.
Correct. That is true, sir.
The illustrations which you have given, sensor connectivity, people, sensors, and actuators, it depends on the nature of application. That means
Yeah,
everything
exactly, sir.
will be connected with the internet.
Yes, that is true, sir.
Slowly, slowly and gradually, everything will be connected with the
Yeah, yeah,
internet.
yeah, yeah. That is true. That is true.
Good,
Slowly.
good.
Yeah, yeah.
Uh, a lot of curiosity because I've the technical background. My area of interest is management HR,
That's
but
okay. Okay.
still, I mean, you station say demo monitor. I mean, see the small kids, her take cares or some others. In the meantime, can attend her household duties
Yeah, sir.
and
Mm.
in touch with kids. How
Yeah,
kids
exactly.
pulse rates, BP rates
Exactly.
is good.
Mm.
So this
Yeah.
type of application already come in the market in other countries. In a,
Yeah, that is true, sir. It's already there. It's already there in the market. Uh,
so that is a lot of opportunity. Lot of opportunities for job for, students, faculty members.
yeah, sir.
Also, I mean, take test in getting and all this
Yeah, that's true.
information pass on covers and all your these simulations were completely practiced. Still, we can wait for a minute or so in case some questions query is there. Is there? Is it possible PPT? How did you measure the voltage using sensor? Sir, one query is there from one of the participants. How did you measure the voltage using sensors?
Madam, generally voltage of sensors, you have these multimeter sensor, na? Multimeters and all. They generally give you the readings now for voltage, current, and all these things. We generally use them only. How can IoT help in controlling corona? I think The thing is, generally, every problem can't be solved with IoT, but we are not
Can,
controlling Corona. Corona, the thing is, I think a lot of watches have come in the market which tell you whether there is a those things are there. Like today, I think even I remember that one of my friend was telling that they're coming up with some wearables where they tell that any nearby any person is there who's corona affected and all. So that way we can do, but not really controlling and all. I think only unless until there's a vaccination, we can't help, madam. That's what. How might cybersecurity affect the development? Yes, yes, security is a big issue, sir. I think, or madam, whoever has asked that question, because we are also working on that. Our target is towards IoT security. Uh, IoT security, because the problem is, as I clearly told you, that IoT devices are all constrained, low power, low memory, and all. But the problem is that's what adding security onto it. Yes, that's a big question mark. We are also trying to look at basically because we need to come out with some lightweight protocols for that. Okay. Yeah, that's what we're also looking into that. And anything is there, I'll get back to you, madam. But people are working on that because that's a big challenge for IoT now. Security is because so many billions of devices into the market, they can easily be getting hacked basically. So for that, we are also looking into how to work on that. Okay, that is there. Cybersecurity is going to affect it. That is surely there. Yeah. Okay.
sir, we can stop our, this session's talk.
Mm.
See you,
Yeah, please.
in the next session. So
Yeah, please.
again, I
Thank you.
express my sincere thanks on behalf of Shankara Institutes
Yeah,
for this
sure. Yeah.
very much, sir. Thank you very
Thank you.
much.
Thank you. Thank you.
So instructions to the participants that the next sessions will start at 12:30. So each one of you is a seat before your systems. So we have break for thank you, audience.
Hello.
Second session will start.
Good afternoon, everyone. This is Dr. Nanda from MNIT. I believe I am online and I am connected with all of you.
Dr.
Yeah. Yes, I can able to listen. Yeah.
Hello.
Yes. Hello. Can you
Dr.
able to
Nanda.
listen to me? Yeah. Is my voice is clear? Hello.
Hello, sir.
Yes, yes, Dr. Nanda.
Yes. Yes.
Good afternoon. I'm Dr. Rathi speaking.
Yes. 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 That is sir.
So you are ready?
Yeah. I am ready.
For minutes, 2-3 minutes more
Okay.
coming.
Okay. 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 Fine.
Oh, yeah.
Yes.
Yes. Dr. Nanda.
Yes, sir. Yes, Rathi sir.
Yes.
Yes, Rathi sir. I
Yes,
am here
dear
only.
participants, now going. Yes. Yes, I'm addressing participants. Participant is back for this session. Sir, this session will be to
Yes.
participants. Yesterday, Dr. Nanda, he touched and defined the concept of artificial intelligence, how computers are doing this, what human beings are supposed to do it. Then he also differentiated what is knowledge, the difference between data and knowledge, and he came out neural network, fuzzy systems, and evolutionary computation forms. He covers multiple layers of neurons illustrated with good examples. These relations. Today, Dr. Nanda, he will talk on the topic nature-inspired computing. This is your topic, sir?
Yes, nature inspired computing.
Inspired computing. Yeah.
Yes.
So, yes, over to Dr. Nanda. Now you can, sir, all the best.
Okay, thank you.
Over to you, sir.
Gratitude.
Yeah.
Hello. Yeah. Yeah. So it's my slide is visible. And audio you can able to listen. Yeah. So thank you. So we are going to discuss about nature inspired computing. So how nature is an inspiration for all of us to develop new things and new techniques, tools, and motivated logics, and how we can able to learn from nature to put artificial intelligence into it. So that is what the motivation of the talk today. So like yesterday I told that nature is one of the main source of inspiration for development of many logics. Like yesterday I told that the ants, tiny ants, they do have the intelligence that if you put some food particles, then the ants will move from their hole to the destination, and they collect all the food and move to their nest. And the path with which they follow from their hole to the food source, that is an optimal path. So that optimal path is known as ant colony optimization, that is inspired from the ants. Like I told yesterday that the uh, dinosaurs, they could not able to survive till date, because with respect to the change in environment they could not able to mold themselves. Whereas the human beings, we are surviving today, though we were there at the time of dinosaurs as well, because it is the survival of the fittest, whichever is the best, that will survive for long. So that is what this inspiration for the nature inspired computing, that from the nature we will learn new things and try to adapt ourselves to the natural environment. So nature inspired computing, I will There are many types, many logics, many inspiration. The aeroplanes, aerodynamic systems has been also evolved out of natural phenomena. There are many vehicles which next generation vehicles, they are also inspired from the natural computing. So I will discuss today about the aspect of optimization, how we can able to use nature inspired competition for an optimization task. Okay, optimization, all of you know, it is either a maximization or a minimization process. That is, either you have to maximize a particular function or minimize a particular function. Why we need optimization? Because we want effective utilization of resources in our engineering. Suppose you have to design a particular building. How much amount of concrete is required? How much amount of iron is required? How much amount of cement is required? And else all means many things are required. Can you optimize that within this much limited resources, I can construct a very good effective building? So that is what an optimization is. Suppose we are saying that a company is manufacturing several kind of vehicles. So how many units of each type of vehicles the company should manufacture so that it will get maximum profit? So that is what maximization of profit, optimization of minimization of resource utilization, that is maximization or minimization of a specific task is known as optimization. That means we are trying to maximize or minimize a particular thing for solving many real life problems. So over here, this is the definition of a optimization problem. That is, either you have to maximize or minimize a particular function within a given specific range. But always the maximization and minimization problems are not so easy as it appears to be, because it always involves with a lot of constraints as well. Constraint means, here you observe that this is an example of a constraint optimization. Means, suppose we are saying that we have to design a building, but we have certain little amount of resources. On the resources, we are saying that the amount of concrete used should not be more than 20 tons, or the amount of iron we are going to use, that should not be more than 30 tons. So like that means we have a restriction. Or concrete plus iron, that should not be more than 200 tons. Then the building will become stable. So the optimization of these two things together, that is on a limitation, that is within a below limit. Like over here in this example, it is given GIX is less than equal to 0. HJX is equal to 0. That means within that limit, we have to do the optimization task. Within that limit, we have to utilize our resources best. So you observe that here there are three functions. Fx is the function we are going to optimize. This Gx and Hx, they are inequality and equality constraint on the function. So either it is a constant or a unconstrained optimization problem. How we normally solve it? If it is a linear problem, then we go for linear programming best solutions. And there are various types of linear programming problems with which we can find out the solutions. Okay. So that is one aspect of solving it. But instead of, all problems are not linear problems. Okay, so linear programming concept and the graphical methods cannot be applied on all linear problems. So in real life, many functions we are using, they are non-linear in nature. So how to optimize a non-linear function? So from our +2 science mathematics, we know how to determine the maxima or minima of a function. Over here, giving you an example of a nonlinear function optimization, that go on calculating the derivative on the function. Derivative or gradient that represents the slope of the curve, and go on calculating the slope till the slope changes either from positive to negative or from negative to positive. So whenever there is change in slope, you declare that one as a optima, whether it is a maxima or it is a minima. To ensure that one, we normally do employ double derivative. So based upon this derivative based concept that you go on moving from the beginning to the end, there are many methods have been developed. Like I can able to say you like steepest descent method, conjugate gradient method, Newton-Raphson method, least mean square method. Like that, many methods, a bunch of methods have been developed based on this statistical analysis to solve the nonlinear optimization problem based on this derivative based approaches. Okay, but the problem happens when we go for multimodal function optimization. What do you mean by multimodal function optimization? You observe in this particular example that here there are more than one mode. That is, here there are 3 modes of operation. The function does not have a single maxima, but it has 3 maxima. This is 1, this is 2, this is 3. When there are more number of maxima and as well as more number of minima, if you can observe that here there are 2 minima, 3 maximas and 2 minimas in this particular function. So it has multiple modes. So it is known as multimodal function. So when we go for a multimodal function optimization, at that time our this derivative based method for calculating the optima, that fails. Why? Because from the beginning over here, when we start taking the derivative and go on in this particular direction, then what will happen? You observe that there is change in slope at this particular point. So it has been declared as a maximum. No doubt it is a maximum, but it is not the global maxima of the problem. So from the end of the curve, if you move in that similar fashion, then what will happen? You get stuck in this particular maxima. So both the things we have got maxima, but these are known as local maxima because they are not the global maxima of the problem within that particular range. So our global maxima that lies over here. Over here you observe that the global maxima is, okay, this is the top at which we are going to obtain the global maximum. So our objective is to find out this global maxima where this derivative based problems, derivative based approaches fails. So how we will get this global maxima in this kind of multimodal problem is a challenging task. So for this is an example, real life example of such type of problem. Like you just have a look at this particular function fxy, z is equal to fxy, okay, and it is such a complicated function. So when we plot this particular function x versus y in MATLAB, you observe that in this particular figure there are many maximas. You observe here there is one maxima, here there is another maxima, here there is another maxima. So three maximas are there. And similarly, there are multiple minimas. Here one minima, here another minima. So three maxima and two minima in this particular three-dimensional plot. This is a 3D plot. Okay. So if we will go for the contour plot of this particular thing, so this is a 2D representation of the 3D plot. Okay, or otherwise known as contour plot. So in this contour plot also it is clear that here there is one maxima, here there is another maxima, here there is another maxima, three maxima and two minimas. One minima over here blue, another minima over here blue. So on this, how to find out the global maximum and the global minimum? Okay, that is a challenging task. So over here for this, we are going for the nature-inspired optimization techniques, because our traditional methods, derivative-based methods or stochastic gradient method or mathematical methods, they fail. The traditional methods, they fail to give us the solution. So that's why we are going for the global, the natural or nature-inspired computing tools. So in this nature-inspired computing, we are going to employ birds, ants, various types of search agents. And what is the objective over here? We will place them all over the curve. So you observe that suppose I have put some of the ants on this particular curve. Okay, some 5 or 10 ants I have put on this particular curve, and I am suggesting that your food sugar particles are here at this global optima. I have put some amount of sugar particles over here. In this particular optima, I have put some sugar particles. So what will happen? All the ants, whatever were there at this element 1, element 2, element 3, 4, 5, 6, all these are ants. So what will happen? All these ants will try to move to this global maxima. Okay. So thereby, all of them, there is highly probability that they all will move to this particular sugar particle place over here at this point. I have put some amount of sugar over here. So all the elements, they will try to move there. Okay. So they can easily avoid the local optima solutions, and they will reach to the global optima. Okay. So they will collectively do their intelligence. They will share the information among themselves. So whichever ant that will reach to the global food particle first, they will share the information among all the rest of the ants, and they all will move there to collect the food and take the food to their nearest hosts. So that is what the inspiration for all of us, that how the nature inspired agents, search agents, whether they are ants, whether they are birds, whether they are honeybees, whether they are XYZ animals or birds or creatures, they put their intelligence to find out the food, where they are getting the food. They try to move there. Why? Because of their survival. Everybody in this whole world try to survive and try to grow. So it is natural for all animals and all creatures to survive. For their survival, they adopt different strategies. Their intelligence they apply. So can we learn the intelligence from them and apply them to solve our engineering problems? So that is what the whole source of motivation for this nature-inspired optimization. You just have a look at these particular problems. So here there are many complicated engineering problems which requires trivial solutions, because in these particular problems you see how many maximas are there and how many minimas are there. Egg holder problem, drop wave, Alpine, Greenwich, Rastigine, De Jong, all these problems has many maxima and many minima. So among these, finding out the global maxima and global minima is really a challenging task. So solving for this kind of real life optimization problem, we definitely require nature inspired computing. So one of the fundamental algorithm which started for solving such type of problem first is known as genetic algorithm. And John Holland in 1975, the first reference I have given of Michigan State University. So he developed this concept of genetic algorithm, which has been very, very popular all over the world. Or this is the first nature-inspired algorithm which has been applied for solving optimization tasks. Davis Goldberg is a student of John Holland, the second reference book, who popularizes this particular algorithm for solving many optimization, machine learning, and various such other applications they have applied. So how we can solve a particular problem, particular optimization problem using this nature-inspired algorithm known as genetic algorithm is the task today. So over here, as we are learning genetic means what is genetic information? That something inherited from the parents to the children, that is known as genetic information. So father, mother, they combine with sexual interaction and the baby gets produced. So the baby inherited some of the genetic property of the father and mother. So that is how the baby, they may become more intelligent than that of the parents. For example, in our childhood days, we were not so much addicted to the mobile phone. Okay. But the next generation babies, now they know the apps, they know the things, and they can able to handle it much smarter way. Because their cognizance, their intelligence is more than that we were there in our childhood. So like that, based upon this particular cognition, intelligence that is getting transferred from father, mother to the baby, to the next generation and to the next generation, that natures are becoming more and more intelligent. So based upon that, this particular algorithm has been developed, and this is inspired by Darwin's theory of evolution that says survival of the fittest. Whichever is best in the society, that will survive for long. Okay. So in a particular genetic algorithm, when we try to solve a particular problem, then we have to initially take some parents. Okay. The parents are defined by a set of chromosomes. So each parent has a set of chromosomes. So over here you observe that I have highlighted a red color line 1011010010 like that. This entire one string is known as one chromosome, and it's one single bit that at last I have highlighted in yellow, that is known as a gene. So a chromosome comprised of many genes. Okay. We are here saying that one particular chromosome is a potential solution of a problem. So when we are saying that there is a problem, then that problem has a solution. That solution is represented by a chromosome over here. So genetic algorithm chromosome means that is a solution of our problem. If it is an optimization problem, then the solution of the optimization problem is our chromosome or one particular row. So this is known as binary genetic algorithm because here everything is in the form of binary bits. That is either 1 or 0, 1 or 0. So each chromosome over here you observe that is represented by a combination of 1, 0, 1, 0. So over here, our entire population that is taken over here is of 5 chromosomes. 5 chromosome means over here we have taken 5 rows. That means this is the first row, this is the second row, third row, fourth row, and fifth row. So over here we have taken 5 chromosomes. Okay, and each chromosome comprised of 10 genes. That means on this particular axis there are 10 values are here. I hope this is clear. This is how we initialize a group of parents or a group of chromosomes for solving a particular task in genetic algorithm. So I believe up to now, whatever I am teaching in the flow, you people are getting it. Are you getting it? Am I connected? Are you people getting it?
Any of the participants?
Yeah. So
No difficulty in
is it
understanding.
yeah. So many of the people are saying yes.
Yeah,
So that means
carry on, sir.
yeah, I am carrying on. So over here,
Yes.
giving you another very simple, easy example that we have to maximize a function. Very simple function. You just have a look that it is comprising of 2 variables, f of x1 and x2. That is z is equal to f of x1 and x2 sin x1 plus cos x2. Okay, and this particular function we are trying to determine the minima of this function, and I have plotted a 3D plot of this particular function. You can observe that here this is in the one axis it is x1, another axis it is x2, and in the z axis this is z. Z is equal to sin x1, z is equal to this, z is equal to sin of x1 plus cos x2. So this is in the z axis, this I have plotted sin of x1 plus cos of x2. Okay, and our objective is to determine the global minimum. So in this particular multimodal function, where the minima is? The minima is over here. Okay, and also there are certain more minimas are also there. One of the minima is also here. So in presence of the multiple minimas, that is one minima here, this is the contour plot, one minima over here, one minima over here. So among these, we have to find out that this is our global minima. We are trying to find it out. Are you getting my point? So as it is a very simple function, sin x plus cos, sin x1 plus cos x2, we know the solution of this. That is when x1 is equal to 3 pi by 2 and x2 is equal to pi, at that time fx1 x2 is minus 2. Okay, that is the solution of this particular problem. Okay, and the global minima is x1 and x2 value are 3 pi by 2 and pi. So pi value is 3.41416 and the 3 pi by 2 value is 4.7124. So how to solve this problem, this simple multimodal optimization problem using our nature inspired algorithm, genetic algorithm. So solving it with genetic algorithm, what we need to do is this x1 and x2, we are going to give initialize chromosomes for it. Okay, as here there are two variables are there. So for x1 we have initialized the thing, and for x2 also we have initialized the thing. So each initially the parent we are taking. So over here C is the parent chromosome. That is 5 parents we are taking: C1, C2, C3, C4, C5. Each parent is representing a potential solution of this problem. So for x1 we are representing it with a 10-bit binary from here to here. Okay, and for x2 also we are representing it with a 10-bit binary. Okay, so both of the things are represented by 10-bit binary. Now if we are trying to solve the sin x1 and cos x2, x1 and x2 should belong to 0 to 2 pi. If you observe this particular problem, x1 and x2, they should lie between 0 to 2 pi. So if we have taken these binary numbers, so these binary numbers, we have to bring them into this particular range 0 to 2 pi, so that we can able to solve this particular problem. So how to bring them into this particular range 0 to 2 pi? Because our problem is, our solution is lying in this range 0 to 2 pi. Always remember that in a practical problem, the thing do not lie from minus infinite to infinite. Okay, because because these are real problems. Otherwise, in unreal problems, that is theoretical problems, we have the integration from minus infinite to infinite. But as it is a practical problem, then it will have definite range. Sine function, its maximum value is 0 to 2 pi because its period is of 2 pi. Cosine function, its period is also 2 pi. So for both these functions, we have to optimize it within the range 0 to 2 pi. So for this one, in order to bring this binary values into this particular range, what we have to do is convert these binary values into the real values and bring them into this particular range. So each of these binary values, that is 10 bits, one set of binary values, okay, we have taken and convert the binary values into decimal values. So how to convert them binary to decimal? That is, we have multiplied it with a matrix 2 to the power 9, 2 to the power 8 into 2 to the power 0. So if you will multiply it, then it will definitely convert from binary to decimal. All of you know how to convert a binary to decimal. So once we have converted it into binary to decimal, then its value will lie between 0 to 2 to the power 10. Here it is a 10-bit binary. Try to understand, it is a 10-bit binary number. So if we will convert it from binary to decimal, its maximum value will be 0, minimum value will be 0, and maximum value will be 2 to the power 10 minus 1. 2 to the power 10 minus 1. So it will lie within this range. Okay. So what is 2 to the power 10 minus 1? That is, this particular thing is value is 1023. So this value, this particular thing is lying within the range 0 to 1023. Okay. But our objective is to optimize the function between 0 to 2 pi. So what we have to do is this decimal value, we will convert it, which is lying between 0 to 2 pi, 0 to 1023. We have to bring it to 2 pi. So this particular decimal value divided by 1023, that is the maximum value. If all of these 10110, if all of them will become 1111, all 10 values, if they becomes 1111, then we will get this particular value 1023. Okay. So if we will divide it by maximum value, whatever value of d we are getting, so this d divided by maximum value, that is 1023, that will bring out a number between 0 to 1. So if we will multiply then this 0 to 1, then that will be get converted. If this 0 to 1 we are multiplying it with a factor 0 to 2 pi, then this particular thing will converted into the range 0 to 2 pi. So this is what is known as range conversion. So we have converted all the 5 chromosome values into its corresponding range R1, R2, R11, R12. So the first portion, that is bringing R11. The second portion is bringing R12. So like that, for all the 5 chromosomes, we have brought these values. And these values R11, R12, R21, R22, all these values are lying in the range 0 to 2 pi. So now, when these values are lying between 0 to 2 pi, now easily we can able to substitute these values in this particular function and calculate its corresponding value. Are you getting my point? So instead of x1, I will substitute r11. Instead of x2, I will substitute r12. So over here, the first function value, that is over here, from there I have brought r11 substituted over here, r12 substituted over here. Then r21 I have substituted here, r22 over here substituted. So I have 5 chromosomes. So for all the 5 chromosomes, I have substituted the values over here. Okay. And I have calculated the 5 thickness. So among these 5 chromosomes, which particular chromosome is best? I can able to find it out. Because whose function, this function I want to minimize. So whose value is minimum? Whether F1 value is minimum, F2 value is minimum, F3 value is minimum, which value is minimum? That I can easily able to calculate. Okay. So now the next thing after the fitness evaluation is putting crossover. The next operation is crossover. In 2 parents, in the original algorithm, it has been defined that 2 parents, they will combine to produce 2 children at a time. So this is the parents will combine, they will mutually exchange the genetic materials among them, and 2 children will be produced at a time. Okay, so this is known as single point crossover. There are also multi-point crossovers are there in the genetic algorithm, but single point crossover is simplified. So over here you observe that what we have done is we have brought 2 parents. Each parent is 10 bit. So first chromosome is 10 bit. Second chromosome is also 10 bit. Okay. So then what we have done is we have defined a point of crossover on which the parents will exchange their mutual information to produce children. Okay. So over here you observe that first parent chromosome, second parent chromosome, they have brought, they produce 2 children, first children and second children. So 2 parents combine to produce 2 children. So how the children get produced from the parents? That this is the procedure. That consider from the point of crossover, first consider the left part as it is, and the right part you swap over. Okay, so over here you observe first part is as it is. You observe 1 0 1 1 0. So over here again for the first child left part 1 0 1 1 0 as it is. Then from here you move to the second parent lower and then calculate this lower part 1 0 1 1 1. So this particular lower part move up, that is the swap over. Lower part will move up and the upper part will move down. Okay, so 1 0 1 1 1 as it is moved up. So now this is the first child that has been produced. Okay, and for the second chromosome you observe left part I have kept as it is, then move on to the top and then keep the right part. Okay, so for the first children the solution is 0 1 0 1 1 and then 1 0 1 1 0. So thereby two parents combine and the left part from the point of crossover they swap over. Upper part move to lower, lower part move to upper. Thereby we have produced two new solutions or two new childrens. Okay, so this is what is single point crossover. Okay, so with crossover we are trying to generate new solutions, and the new solutions will be better than that of the parents solution. Okay, so you observe here also in the animation I have shown the same thing, that two parents, the upper part is moving lower and lower part is moving upward. Okay, and that is how we produce two parents combined to produce two children, two crossover children. Now the next operation is known as mutation. Okay, so in this mutation process the crossover children, they have been produced, they need to be taken care. Okay, so for taking care all those solutions, what we need to do, whether we with the crossover, if the solutions have reached 90% accuracy, then with mutation we will incorporate some of the more bit exchange over there, so that the solution becomes more fitter, from 90% to 99% accuracy. Okay, so when it will, the accuracy will become more and more, they can able to avoid the local optima and they will try to converge to that global optima. At that instant of time the accuracy will improve. Okay, so for this mutation what we will do, we will apply the mutation process on the crossover generated children. So with over here the children have been produced, you can able to observe here two children have already been produced. So on these two children, so we will apply the mutation mechanism. So how to perform the mutation? So randomly pick up some of the points. Okay, so two children's there it has been produced. So over here we have taken 2 points on the children's. You observe the yellow highlighted points. Okay, 2 points selected randomly pick 2 location over there. Then from there you check that whether there is a 1 is there or there is a 0 is there. So if there is a 1 is there, convert that 1 into 0. If there is a 0 is there, then convert that 0 into 1. So you observe that at the first point there is a 1 is there. So that 1 I have converted it into 0, highlighted in pink over here. Then here there is a 0, that 0 has been converted into pink color 1 over here. Okay, so like that we have obtained 2 new mutated children with crossover. From the original parents we have applied the crossover, we have generated 2 children. On these 2 children we have applied the mutation process and we have obtained 2 mutated children. Okay, So this mutation mechanism is also highlighted over here. You observe that initially a red point is there that is converted and got converted into green point. So red may be representing 1, green may be representing 0. So initially when a red point was there, that get converted into green. 1 has been converted into 0 or 0 has been converted into 1. So this is single point mutation. Now we have initially taken some of the original parents. Okay, like over here 1 0 1 1 0 0 1 0, 5 original parents we have taken. And after crossover operation, we have obtained 2 children. Then we applied mutation mechanism. Again, we have obtained 2 children. Okay. Now, what is the family size that has become? 5 parents plus 4 children. Total become 9. Okay. Out of these 9 solutions, only 5 best solutions will survive for the next generation. Okay, out of 9, 4 people will die and only 5 will survive for the next generation. So which 5 will survive for the next generation? That is known as survival of the fittest. Who will survive for the next generation? According to Darwin's theory of evolution, survival of the fittest. At times we observe that if the children are not so healthy, they may die early, where parents are staying up to 100 years. Okay, so who will survive for the next generation? Whether the parents will survive for the next generation or children will survive for the next generation, that will be decided over this particular procedure. So you have to take the fitness of all the 9 people. How to calculate the fitness? That I told, these are binary numbers. Convert these binary numbers into decimal numbers. Bring them into the range 0 to 2 pi. Substitute these values in the fitness function, that is sine of x1 plus cos of x2. In that particular function, you substitute these values and calculate the fitness function values. For all the 9 values, we will get 9 fitness functions. So among the 9 values, which 5 values are the lowest? Because we are minimizing this function. Which 5 values are the lowest? Those 5 values which are lowest, they are the best values. So for those values, we need to keep them for the next generation. And the entire process will be repeated. Okay, for generation to generation, generation to generation. For couple of generations, this will repeat it. So this is what the flow of genetic algorithm until and unless we reach the entire solution. So this is the flow of the algorithm. You should stop until and unless your minimum has been achieved. That is, this particular process you will run it for a couple of number of times. Okay, that till you have achieved the global convergence or global solution. Okay, so once you move on achieving this, then finally you will observe that all your solutions have achieved convergence or they have reached to this particular global minimal value. All the solutions will come and achieve this particular minimal value, that is sine 3 pi by 2 and cos pi. Okay, and your global optimal value you will achieve as -2. So I believe I have explained you this particular algorithm with this simplified example of minimizing a 2-variable multimodal function. If there is any doubt on this, you can ask me now. Or you can type in the chat box.
Wait for chat box. You can put few words, sir, wherever there's any doubt.
How to decide the yeah how, yeah.
Yes, one.
So about the fitness function. So it is defined for a specific problem. So here for this particular problem, I have defined it as sine x1 plus cos x2. This is the fitness function. This we are trying to minimize. So the function which we are trying to minimize or maximize, that is known as the fitness function. In many of the engineering applications, we try to minimize the error square or mean square error. We try to minimize between any desired signal and the model output. We try to minimize or try to optimize error square. So that is what the fitness function is. Here for the mathematical function, we are trying to minimize the sine x1 plus cos x2. So this is about the fitness function. So for any particular problem, the fitness function is defined, or you have to define it in this particular way. Error square you have to minimize, sum of square error you have to minimize, any particular function you need to minimize, that is known as the fitness function. Any other query on this concept? How it is used with an example is not the objective function we want to minimize. So this is a example I have given
that we want to minimize.
That this sine, yeah. So the function either it has to be minimized or it has to be maximized. So over here sine x1 plus cos x2 we want to minimize over here. How fitness and objectives are different. Look, fitness function and objective functions are not different. I mean to say, fitness function is equal to the objective function. Fitness function, real life example if possible. So real life example is a system identification process. So let me share with you another slide in which I can able to tell you about a real life example. So here is a real life example for this. This is a system identification problem. Try to have a look. In this particular problem, here we have a system. Okay, this system is it may be any particular real life system. Okay, suppose it is a machine. Okay, and we want to develop a prototype of the machine. Okay, or a model of that machine. Why we want to develop a model of that machine? Suppose a car is there, we want to design a model of the car. Why we want to design a model of the car? Because if we can able to design a model, then if the model is working fine, then in the real life, if you will do the simulation and it is working fine, then in the real life also, if you implement the car, then that will also work fine. Okay, without simulation, without modeling, if you will do a car design, then it will be automatically lead to a failure. Okay, so the car has several parameters. It will take certain input and it will give you the output. Okay, your machine, your electric machine, it is taking your voltage and current and giving you the RPM, revolution speed. Okay, so any particular modeling, if it is taking certain input and giving you certain output, then that is a particular system. So here this system has a transfer function Pz. What is transfer function? That is defining the input and output relationship between the system. So this input has been applied to the system and that is giving me a output Yk. And you know, any of the real-time system, it has certain noise associated with it. Why a noise will be associated? Because of various temperature, weather condition, different type of thing, or faulty measurement, reading, recording. So for that one, noise also come. So any real life system will have a noise component associated with it. So along with the system transfer function and noise, we are getting the output Yq. So the input has been applied to another model, to the model, which is giving us a output y cap k. So if this model, the system is like this, if there is a model and this model is giving me the output which is same as that of the system output, then we can able to say that the system and our developed model both are same. Means we have taken a prototype of the car and the car is giving us same output that of a real car, then we can say that the model is working perfectly. Or if there is a machine, that machine is giving us whatever output in the form of revolution per minute, then the simulation model that is also giving us the same thing as that of the revolution per minute, then we can say that the model and the original system, they are same. But normally this yk and y cap k are not same initially. So between these two outputs, there are a lot of errors are there. This ek, you can observe that the system output to the model output we are subtracting, and this is an error. So our objective is to minimize this error so that the model output and the system output will become same. And this particular thing is known as a system identification problem. So our objective is to put over here this intelligent algorithm, nature inspired algorithm, adaptive algorithm, so that the error has to be minimum. Okay, so such a type of system, if you will implement, then the error will be minimized. So like I told previously, sin x plus cos y, that has to be minimized. So over here the error has to be minimized. If we will solve this particular problem by taking a real life example over here, like a particular transfer function along with the input, along with the noise, if we will calculate, then the error has to be minimized. You observe over here the error in decibel. So 20 dB and 30 dB noise has this at 20 dB, 30 dB noise, the simulation has been done, and you observe that the noise has been reduced. The noise is reducing. MSc in dB, 20 dB, 30 dB noise has been settled. So this is the simulation and minimization of the error for such a type of practical system that you wanted to know about. This is a practical example of that. So you would have understood about the fitness function and such a practical example of the system. So got an idea about it? Any more queries on the genetic algorithm, or I will simply go ahead to tell you a little bit more thing about nature inspired optimization.
Yes, Dr. Nanda, you can.
Yeah. So
Yeah.
over here, I want to tell you another interesting application of this nature inspired optimization algorithm. that is known as particle swarm optimization. Okay, so it is a algorithm that is derived from the intelligence of birds or fishes, how these creatures they grab their food or how they collect their food, okay, in their environment. Based upon that, this particular algorithm has been derived. It is the collective effort of a group of birds, group of fishes, collective intelligence of a number of creatures we can able to see. So this is derived from by Everhart and Kennedy. The first paper you can able to observe. None of them are engineers. They are psychologists. Okay, they understood the behavior of the natural phenomenon, whatever they observed with these species, and they tried to convert that particular thing into a swarm intelligence algorithm. Swarm intelligence means collective behavior of a swarm, that is a group of animals or a group of birds and creatures. Okay, based upon that, there are several publications also. And now this particular particle swarm optimization is very popular, and it has been widely applied like genetic algorithm to all the research. So what is swarming? To explain you, when we move to any of the pond, then normally you wish to feed certain things, to feed certain food to the fishes. Okay. So when we put a food particle in the pond, then what will happen? The fish which is near to that particular food particle, that will observe that particular food. Okay, oh, I have got a food particle. Somebody has given a food to me, and I have got this food particle. Then what will happen? It will not alone grab it, but it will observe its food size. Look, this much amount of food is available. Then what I will do, that I will inform it to all my friends and let all of them join me, and we all will have. So the fish will move to the near the food particle. It will check its size, things, everything, and then inform all its friends. So over here with animation you observe, it went there, moved, and informed all its friends, and they all moved there to grab the food. This is what in real life happens. Why they all share the things with each other? Because today I have got some food. Tomorrow my friend will also get certain food. If I will not share it with everybody, they will also not share it with anybody. So then all of us will starve one day. Are you getting my point? So they have a collective intelligence that you check the food and you inform everybody. All of us will come and grab the amount of food. Okay, this is what is known as swarming. And this particular process of movement has been encoded in the form of an algorithm. This is our pond. Okay, so in this pond, this red one is the food particle. Red one is the food particle. Okay, so over here, suppose this, in this particular thing, every fish is represented by its position as well as velocity. Why velocity? Because every fish is moving in certain way. Okay, it has a position and it has a velocity. So xi1 is its position, vi1 is its velocity. xi2 its second one's position, vi2 its second one's velocity. So like that, there are d number of particles are there, and each one is associated with a position and a velocity. Among these, which one is close to the food particle? That will first observe that particular one. So over here you assume that this xi3 and vi3 is the thing which is close to the food. So that will try to move to the food first, and that will inform all of its friends. Then all of them, you observe in the third thing that all the particles are trying to move towards the food source. Okay. So over here, that is mathematically modeled like this, that every ith particle is having position in every dimension. Suppose it has a 5 or 10 dimension, then or 3 dimension, d is equal to 1, 2, 3, 3 in the 3 dimension, they try to move. Okay, this is the xi is the position, vi is the velocity associated with every particle. Okay. So the best value of position, that is the best value associated with every piece, is known as local best position, and whichever is the best among the entire group, that is known as global best position. Okay. So I will tell you about this local best and global best position. There is a difference between them. Okay, and if you will understand, then this algorithm will become very, very easy. Okay, suppose every fish has their own experience of swimming in the particular pond. Okay, if we will say that among all these things, somebody has got a food particle, and that is telling all of us that, look, I have got the food particle of this much amount of size, and all of you follow me. Okay, then we have to follow that particular one because that fellow has the food. Okay, and that fellow is known as the global best position. But every individual do have their own experience of swimming in the pond and finding out food. So I may able to say that, look, that fellow is swimming and that fellow has got the food, and that is the global best. But I know how to find out the food. So I may able to move in that particular direction, or I may able to little bit deviate and go ahead as per my wish. When I will do that one, when I do have the past experience of getting more food than whatever that fellow has got till now. That means I want to say that suppose I have appeared to examination. In my 10th, I have got 80% of mark, and in my 12th, I have got suppose 90% of mark. Okay. Or I can say in my 10th, I got 90%, and presently I have got 80%. Okay. And presently my class topper is 85%. Now I am in +2 science, okay, 12th standard, and my CGPA is 80%. My class topper is 85%. And in my 10th, I have secured 90%. Are you getting my point? So when I will appear for another exam, suppose for competitive exam test, then at the present time, my topper is that who have secured 95%, sorry, 85%. Okay, I cannot able to ignore that that fellow has got 85%. That is my class topper now. That is the global best position, a single position, because that is the topper of the present class, 85%. But I can able to ignore him telling that in my 10th, I have got 90%. So I know how to secure 90%. So in the next competitive exam, I will secure more than you because I know how to read. But at present, you are only, but I can never able to ignore him because at present, he is the topper with 85%. I have my past experience, my record is very good in 10th. But at present, the topper has secured 85%. So I have to follow in both the things, that the present topper I cannot able to ignore, and my past experience also I cannot able to ignore. So this is the thing about every individual past experience is known as local best, and the present topper is known as the global best. So global best is a single entity and local best is always a vector. That means for every individual phase, the individual experience is there. So if there are 10 phases, then all of them do have 1 local best. Okay. So now every phase, how it will fly in the, how it will swim in the water. It has to have certain velocity update. It will have certain position update. So the velocity update is defined by this particular equation. You observe what is there in this particular equation. The velocity get updated with the previous velocity. Why? Because if somebody is flying in a particular direction, it has a tendency to fly in that particular direction. Okay, so always at any k plus 1, it will move in the same direction. That is known as inertia of velocity. That is, with which velocity you are moving or swimming, you have a tendency to move in that particular direction. Slightly you can change left, right, but you cannot be 180 degree moving back. Have you ever observed any fish moving in some direction and 180 flip and go in the opposite direction? That never happens. Okay, any bird flying in the direction and 180 degree flip and go in the opposite direction, that never happens. It has to either till little left, till little right. Okay, so whatever is flowing in a particular direction, that has to tendency to flow in that particular direction or swim in the particular direction. That is inertia weight. W is inertia weight along with the previous velocity with which it is moving. Okay. Then from there we are going for two important things, that is the local best minus the present position and global best minus the present position. You observe C1 R1, these are constant, and C2 R2 are another two constant. And this is local best minus the present position and the global best minus the present position. Okay, two difference. That is my own personal best minus our present position and the present topper minus the present position. So that is how the velocity get updated. Once the velocity get updated, the position get automatically updated. So observe the next equation. The xid k plus 1, the position get automatically updated with the previous position plus the present velocity. So how I am adding the velocity with the position? Because velocity within a time is known as position. If it is within 1 second, the update, that is nothing but the position. Okay. So the maximum, now if we are moving with certain velocity and certain position, that means we need to restrict them. Why to restrict them? Because if they will move with very high velocity, then what will happen? Like dolphins, they jump all over the water. Will they get the food over the water? They will not get the food over the water. Like their position, they will get inside the water. Okay, so we have to bound them in the boundary, that they should not move with such a high velocity that they will go out of the pond. Okay, so that's why there is a restriction on the maximum and minimum velocity over here, and there is a restriction on the position over here, that is maximum position and the minimum position. With this particular thing, they will go on updating the thing. So over here, that same thing has been encoded over here in the form of the algorithm. So over here, for every particle, you calculate the fitness value and determine that what is the global fitness value. So fitness value and objective value, that are same, I am saying. So over here, the fitness function you calculate for a maximization or a minimization task. So giving you the same example, which we have solved the genetic algorithm. So over here, what we are going to do, suppose 4 particles we have taken to solve this sin x1 plus cos x2 problem. So for every particle, we have defined the positions and corresponding velocities. Here 2 variables are there, x1 and x2. So x1 and x2 values we have taken in the range 0 to 2 pi. So you observe x1 and x2 values we have taken between 0 to 2 pi. Then the velocities you observe, I have taken it within the range -1 to 1. So the velocities are within -1 to 1 and the positions are between 0 to 2 pi. So now these position values, I am substituting it in this particular function sin x1 plus cos x2. So x1 and x2 values, first 2 values over here, the p1, we are substituting over here in this particular function. And we have obtained the fitness value as 0.4674. So these 2 values substitute over here and you have obtained the first value as 0.4674. So like that, for the second particle, you substitute these 2 values. Then you obtain the fitness value as this. Third particle you substitute, fourth particle you substitute. For every 4 particle you substituted. And among these 4 values, fitness values, you have obtained fitness function or objective function that you have calculated. So for among these, you observe that this is the minimum value, minus 1.5848. So this is the minimum value. Okay, or the global, its corresponding global best position is 3.8129 and 2.8681. So this is the global best position. That means it is always a position, okay, and compared to the corresponding fitness value. Okay, so P3 is our global best position. Now we will update with our velocity and position update equation. We are going to update it. So you observe that this velocity and position update with the inertia weight 0.4, C1, C2 constants and R1, R2 random numbers, we have updated it. So updating the values, updated velocities, that is the velocities got updated and positions got updated with these 2 equations, okay, that I defined. So with these updated velocities, now we will calculate the fitness function again. So from the 3rd position, now the global best has changed to the 4th position. And you observe that previously some of the values are positive and some are only one value is negative. But after updation, you observe that all the 4 values have come negative. So that means all are moving in a particular specific direction towards the global best. So like that, while going on, iterating it for a couple of iterations. So now the next generation, the global best, we are going to obtain the global best position like this, almost, which is very close to the solution we achieved earlier. So over here, like that, every iteration, you go on updating the velocity and position and calculate the fitness value. That updated fitness value you always used to calculate. Okay, and go on doing it until and unless you achieve the convergence. So over here, this process will get repeated for a couple of iterations. So you observe this process will be repeated for a couple of iterations till you got the global convergence, and this is the global converged value. .7124 and 3.1416. For the same problem, I told about 2 very important algorithms, that is genetic algorithm and particle swarm optimization. And we have observed that both the algorithms are coming into the same global minimum with the nature-inspired optimization algorithm. So if you have any doubt on this, you can ask me.
Yes, participant now is open for query. 5 segments are open for queries. In case you have any doubts, you may raise to.
I have tried my best to simplify the algorithm so that the people can easily able to understand this nature inspired algorithm with this example.
Example very simplified, illustrated. Repetitions was
Yes,
very good, well taken by the participants.
Run both the algorithms to find maxima and minima. Yes, you can able to run both the algorithms and you can compare their convergence curve, which will be converging fast, which will be converging slow, that you can able to observe. So both the algorithms you can run and you can able to find it out which performance is better.
This is inspired.
Because inspired because it is the source of inspiration. Well, this algorithm I have told that is inspired from fishes. So how fish are moving in a pond, from there we have got the concept to apply it in this algorithm, to develop this algorithm. Yes. So the first one, genetic algorithm, that is inspired from Darwin's theory of evolution. So survival of the best parents. Yeah, Darwin's
survival
theory.
to the yes,
survival.
Charles Darwin theory. Yes,
we are getting the concepts, so that's why.
But these days, this taken a different pace to the
Yes, yes.
The change.
Yes.
Because the technology is so, I mean, so many inroads have been made in different sphere.
Yes.
In the talking to Mr. Srinath, because Minister he was making a speech to the parliamentarians, and the way he was saying, I also got surprised. What if these things can also happen? What he was telling, that who is under influence of some intoxicants, he cannot drive the vehicle. Even he put his key in the put the accelerators or gear, the vehicle will not move, because sensors, connectivity, people and processes, they are all connected to each other. So they are going to devise that type of technology so that these type of people, they can drive, they cannot move the vehicle. They will immediately be caught. Similarly, a person wearing the belt and driving the vehicle, he will also be, I mean, caught by the nearest police stations. So see the technology, how it so much inroads in various sphere of human activities, so that human interaction, I think they will come when human intervention be completely minimized.
Yeah, that is what the future is.
So that we can conclude. And my address that tomorrow, that is at 10 o'clock to 7 will be there. Today's answer you will coordinate, because Shankara group of institutions, they want to honor you with the certificate of remembrance. Just wait for a minute. That's all. applications or this
Thank you.
is organized by Rajasthan Technical Universities and Shankara Institute of Technology. So this is a certificate of appreciation, sir. And Shankara Group of Institutions also put on records your appreciations for deliberations that you have made a very complicated, topics in a very simplified way, and you have nicely taken care of how to, what is defined in a very logical terms, this artificial intelligence, Internet of Things. So we express our gratitudes. So thanks to you.
Thank you. Thank you all. Namaste.
Thank you. Yeah. No. Okay. Okay. Ask today is over. तो मैं सिस्टम बंद कर देता हूँ यहीं से ना रेड बटन